Okay, so this will become N, Cp, Cv. For a diatomic gas, the value of Cv is 5R.
Molarity becomes 0.01. That means the pH will be 2.
So we are left only with T square here in the numerator. Now I will apply LH rule, L'Hopital rule. Limit T approaches to 0.
Hello, dear students. My name is Vikas Agarwal, and I'm discussing the third scholarship test of Eklavya. So let's begin. So the first question says that we want to throw a projectile with a speed of u at an angle theta from the horizontal, such that at some point of the trajectory, the projectile travels perpendicular to its initial velocity of projection. So let's understand what the question is saying. Let's say if this is the horizontal ground, and if we have projected something from here with a speed u at an angle theta, then what kind of trajectory it follows? Let's focus on that. What happens is that it travels like this and then it hits the ground. And you might be aware of this, that when it hits the ground, it makes an angle theta with the ground. All right. So whatever was the angle of projection, it strikes the ground at the same angle in the downward direction. Now, if you notice that in course of its motion, the velocity would have pointed in this direction, then in this direction, then in this direction, then in this direction. So you will notice that the velocity vector is making decreasing angle with horizontal, making a 0 degree here at the highest point, and then it continues to decrease and it becomes theta. So at any point in time, if it were to become, if this vector were to become, or the velocity vector were to become perpendicular to the initial direction of motion, then this theta should be more than 45. Because if you think of it, what is happening here? Like whatever angle you are throwing at, let's say you are throwing it at 60 degree, then the velocity vector is assuming angles such as 59, then 58, and so on, then 0, and then so at some point in time, it will make 30 degree with the horizontal. And when it makes 30 degree, if you shift this arrow to this place, you will find that okay, these have become perpendicular to each other. So for this to happen, for the velocity vector of the projectile at any point of its motion to become perpendicular to its initial velocity, the angle of projection, we have to keep it at above 45 degree. If we have done that, then we will certainly get a situation when the velocity becomes perpendicular to the initial velocity. And therefore, you can have any value, but theta needs to be more than a certain value, and that certain value is 45 degree. So option A would be the right one here. All right. So this question will have answer as A. We'll go to the next question now. Now this question says a clamped string is oscillating in the nth harmonic. Select the correct alternative. All right. So let's say if a clamped string is oscillating, let's say it is oscillating in the fundamental mode. So in the fundamental mode, only one loop is formed. Okay, and the energy of oscillation is given by it's proportional to frequency square. Like it's a half m omega square a square. Okay, like this. So what is happening here is that mass is same, omega is same. Like if we increase the number of loops, that is, if let's say that figure that I've drawn right now, it depicts the fourth harmonic. So in this case, omega will become 4 times of the initial value. All right, m will remain same, a will remain same. The question says that a is same. So if omega has become n times of its initial value, then the energy will become n square times of the value of the fundamental frequency. So option A would be the right here. Okay, so for question number 2, option A would be right. Now, in this question, what is happening? This question requires you to have some prior knowledge of what omega would be in such a situation. For example, if I have one block of mass m1 and there is a spring here and there is another block of mass m2 and let's say the spring constant is k. Okay, now for such a situation, what would be the value of omega? So if both the blocks are allowed to move freely, in that case, omega is given by root of k upon reduced mass, where reduced mass is written as m1 m2 upon m1 plus m2. So this is how we write reduced mass. And in the present scenario, the springs, in the manner in which they are connected. So this is the first formula that you should be aware of. The second formula, if the springs are connected in series, they are connected in series, then K equivalent is given by, like the formula is 1 upon K equivalent is equals to 1 upon K1 plus 1 upon K2, which after a little bit of rearrangement transforms into K1, K2 upon K1 plus K2, which basically means that in the present scenario, K equivalent would be 4K into 2K divided by 6K, which ultimately becomes 4K by 3. And the reduced mass would be M into M upon M plus M, which makes it M by 2. And therefore, the omega would be root of k by m. So 4k by 3 and then m by 2. So it becomes root of 8k by 3m. So that is omega. Now time period is given by 2 pi by omega. So option D should be the right answer. All right. So if you were aware of these things, then the question was easy for you. If you were not aware of these things, then this question was definitely difficult for you. Okay, next we go to the question number 4. It says a load of 31.4. Now, guys, notice the value. Pretty odd or peculiar, but if you notice it carefully, this is 10 times of pi. We generally write pi as 3.14, so it's 10 times that value. So I'm expecting that somewhere mass would be needed to be divided by pi so that we end up with a round figure. Let's proceed. A load of 31.4 kg is suspended from a wire of radius this much and density this much. Okay, so you see that the radius is quite small, the density is whatever. Okay, and the length is not given. The calculated change in the temperature of the wire, 50% of the volume and the gravity is converted into heat. So there is a wire. Okay, there is a wire, and the radius is pretty small. Let the length be L, and then the wire was like this. And then what happened that when we hang a block of, let's say, m mass from it, so it elongates. Okay, let's say it elongates by delta L. Okay, so how do we find this elongation? We find this elongation by using our conditions of elasticity. So mg becomes the load. Here we are calling mg as load because we are assuming that m is much greater than small m, where small m is the mass of the wire. Okay, why am I doing that? I think the radius is pretty small. It's 1 millimeter square. So if I try to calculate the length, or the length is not given, so I can't even know the mass of the wire. So I'm assuming that this is the scenario. So the applied force, or the force that is causing the deformation, that is mg divided by cross sectional area, where a is the cross sectional area of the wire, so that becomes stress is equals to Young's modulus into strain. So from here we can calculate the value of delta L. So delta L will be given by mgl by Young's modulus into a. Okay, this is L. Now the work done by gravity, how will you write the work done by gravity? That would be mg into delta L. Okay, delta L. So I will write it at mgl upon ya. So this is work done by gravity. Half of this, okay, so half of this is converted into heat. So this is the amount of heat, and we are assuming that this entire heat was absorbed by the wire itself. So that will lead in a increase of temperature of the wire. So we will write mass of wire into S into delta T, and from here we are going to find the value of delta S. So I will now finish this calculation. So delta T would be given by mg square. You notice here it is mg square. So because I've taken care of it here, I'm cutting it from there. Then L. So this L, I will write it as small L maybe. Okay, L I've taken care of, divided by 2 ya. Okay, fine. Then divided by mass of the wire. Mass of the wire would be density of the wire into cross-sectional area of the wire into the length of the wire, and then S. So we have to finish this calculation. And in this calculation, if you notice carefully, students, what has happened is that L gets cancelled. So L was not even given to us in the question. So that is a good thing. So mg. Okay, mg. M was 10 pi. G is let's see, well, if a certain specific value of G is given. Yeah, G is given to be 9.8. Okay. So I will write M as 10 pi. So 10 pi square. So that will become 100 pi square into 9.8 into 9.8. Okay. So I have taken care of this. I've copied the numbers here. Divided by 2 into Young's modulus. Now, how much is Young's modulus? Now, the Young's modulus is given to be 9.8 into 10 raised to power. So 9.8 into 10 raised to power 10. So that is Young's modulus into the cross-sectional area. Now, again, a square is there. Okay, so I've taken care of this. I've taken care of this. A square I'm writing. So a square will become pi square into R4, radius raised to power 4. So radius is 10 raised to power minus 3. Power of 4 will give 10 raised to power minus 12. Okay, so I've taken care of this also. And now the specific heat capacity. The specific heat capacity is how much it is given to be 490, and everything is in SI units. So I will just write it as 490. Now I need to finish this calculation. So let me change the color of the pen so that you know what I'm cancelling out. So if you see from here, pi square goes, okay, pi square goes, one of this 9.8 also gets cancelled. Okay, this 490. So I can multiply with 2 and I can multiply with 2 here. I've done this because now it becomes 980. Okay, so it becomes 980, which is 9.8. So um, if I cancel this with this entire thing, then I will have 100 here because 9.8 times 100 will become 980. Okay, and then this 100 can be cancelled with this 100. So now in the numerator, I see a 2 which gets cancelled. So the numerator is 1 now, and in the denominator, we have 10 raised to power 10 and 10 raised to power minus 12. So I can cancel this out and I can write 10 raised to power minus 2. And what else? I think, is there anything left here? Let me just check regarding this. Oh, in fact, I noticed that this delta, this row, I did not strike it out, which basically means that I forgot to copy its value. So this way of calculation can actually prevent you from committing calculation mistake also. See, I felt something was odd, and because here I don't see 1 upon 100 anywhere, because right now I was getting, or 100 maybe. So I thought that maybe I missed out something, and I noticed that this row is not struck out yet. So I forgot to copy its value, so I'll do that now. So row was given to be where row is given to be 9,000. Okay, so it will become 9,000, and when I multiply 9,000 with 10 raised to power minus 2, okay, what I get is 1 upon 90, and I do see that in one of the options. So option C would be the right option here. So option C is indeed the option, so that we are getting. Now we go to the next question. Now this question says, salt particles of radius 10 micrometer is on the top of a deep lake. water. Its density is given, the viscosity of lake water is given. Notice that the viscosity is given as 1 millipascal second. Okay, so this m is milli. Okay, and the density is this much. Okay, so guys, we have to simply calculate the terminal velocity. And to do this question quickly, you should be able to recall the formula of terminal velocity. It is 2 by 9 r square g by eta, and then the difference of the density of the solid minus density of the liquid. So we just have to substitute the number and finish the calculation. So 2 by 9 into r square. Now r is given to be 10 micrometer. That is 10 raised to power minus 5. Square of that will become 10 raised to power minus 10. And then value of g is given to be 10. Eta is 10 raised to power minus 3. And then the difference in the density. So the mud particle, so this mud particle has a density of 2000. Water has the density of 1000. So the difference will become 1000. Okay, so we just need to finish this calculation now. So from here, what do I see is that let me change the color so that I can cancel out things. So this becomes 10 raised to the power minus 7 and then minus 3 because there is 10 raised to the power 4. So 2 by 9 into 10 raised to power minus 3 would be left here. Okay, so this is the terminal velocity. And now notice that this terminal velocity is in meter per second since we have to give the answer in millimeter per second. So we can now write it as 2 by 9. Just a minute, guys. We can write it as 2 by 9 into millimeter per second. So how much is 2 by 9? 1 upon 9 is 0.11. Double of that is 0.22. So option D would be the right answer. So the correct answer to this option D. That was question number 5. Now we go to question number 6. Question number 6 asks us about the efficiency of a cyclic process. Now, guys, what is efficiency? Efficiency is work done divided by heat supplied. Now, keep in mind that the denominator here is only the heat supplied. It is not the net heat supplied because the net heat supplied in a cyclic process will become equal to the work done by the gas. So the ratio will always turn out to be 1. So in denominator, we have to substitute the heat supplied to the gas. Okay, now let's do one more thing. If I consider the temperature at A as T naught, all right, notice this. Then at B, the temperature will be double of what it was at A. So it will become 2 T naught. And at C, the temperature will be 4 times of what it was at A because the pressure volume product becomes 4 times of what it was at A. So here the temperature would be 4 T naught. So I now know the temperature in terms of T naught at all the 3 points. Okay. Now how do we write the work done? Okay, so work done, and one more thing, if the temperature at A is T naught and the pressure and volume are P naught and V naught respectively, then we can definitely write that P naught V naught is equals to N R T naught, and N here is 1 mole actually, so we can write it as R T naught. Okay, now work done is area of the triangle. Area of the triangle is half into base. Base is P naught into height. Height is V naught. Okay, so the work done is P naught V naught by 2, or in other words, it is R T naught by 2. So that is the work done. Now we have to worry about the heat supplied. So pay attention to it in this. This process is isochoric heating process because the volume is not changing, but the temperature is increasing. It is isochoric. So in this, we would have supplied some heat, and that heat, how do we write that heat? So that heat would be written as NCV delta T. Okay. So this is the heat supplied in the process A to B. Okay. So this is heat supplied in process A to B. Let me call it as Q supplied 1. Okay. So this will become N CV. For a diatomic gas, the value of CV is 5R 5R by 2, and delta T is 2 T naught minus T naught, so this is T naught. So again n is 1, so it becomes 5R T naught by 2. So this was heat supplied in the one of the process. Now heat supplied in the second process, that is the BC process. BC process is isobaric expansion. Okay, so NCP delta T. All right, so N and CP would be 7R by 2. And how much is delta T? So the temperature changed from 2 T naught to 4 T naught. So the delta T would be 2 T naught. So this becomes what? 2 gets cancelled, N is 1. So this becomes 7R T naught. All right, and in the last process, which is like some process, in this process, if you see the volume of the gas is decreasing, that means the work done by the gas is negative, and also the temperature is decreasing. So work done by gas is negative. All right, I'll write it here. Work done or delta U is negative, work done is negative. This means that Q is negative. That means gas rejected heat in this process, so we don't have to worry about that. So the total heat supplied is 2.5 R naught plus 7 R naught, that is 9.5 R naught, and the work done was 0.5. So the efficiency would be 0.5. R T naught will get cancelled, and here 7 plus 2.5, that is 9.5. So it is 5 upon 95, and this is in fraction. If you want to express it in percentage, then it would become 5 by 95 into 100, which we can expect is somewhat more than 5. So out of the given option, I believe this is the only one which is closest to 5 and more than 5. So option B should be the right. Of course, you can finish the calculation properly and you can check it, but I think there is no need to finish the calculation right now. All right, so option B is the correct one. So that was question number 6 for you. Now we go to the next question, which is question number 7. It says a gas mixture consists of 2 moles of oxygen and 4 moles of argon at a temperature T, neglecting all vibrational modes equal in degree of. So how do we find the equivalent degree of freedom? The formula for this is N1 F1 plus N2 F2 divided by N1 plus N2. So we simply apply this formula. Oxygen has 2 moles and degree of freedom for oxygen. Oxygen is a diatomic molecule, so 5. Okay, degree of freedom for argon is 4, and argon is the monatomic molecule. For a monatomic gas, the degree of freedom is 3 divided by total moles, which is 6. So this becomes 10 plus 12, 22. 22 by 6, so that becomes 11 by 3. We do have an option of 11 by 3, so that option should be the correct one. So option B is the right one here. Next, we go to question number 8. Okay, this question says total time elapsed for a hollow sphere of inner radius 3 centimeter, outer radius 6 centimeter, density is given, specific heat capacity is given, emissivity is given to cool from some temperature. Okay, so guys, I believe that this question is going to be a calculation intensive question. I see a lot of numbers in this question. And of course, I know from experience that a question involving radiation where we have to calculate the time, it takes a bit of time. So if you're in exam you might have left this question for later on. If you already know that these questions in which radiation is given and the time is asked, they take a bit of time and they're calculation intensive. Right now, let me do the solution. So what is this? This is 727. So this is 1000 Kelvin. Okay, this is 1000 Kelvin. Okay, and what is this? This is 500 Kelvin. So what is happening is that the temperature of a sphere is decreasing and it has decreased to half of its initial value. So that is what is happening. And the sphere, okay, if the inner radius is r, the outer radius is 2r. Here r represents 3 centimeters. So I'm trying to notice the numbers. There are some patterns given in the numbers. So the temperature has become half. The inner radius is half of the outer radius. Density is given. Okay. So what is happening is that this solid or this sphere would radiate heat. Okay, it would radiate heat if its temperature at any point is T. Then the rate at which the radiation will take place or the power radiated would be sigma. Then epsilon. Epsilon is given to be zero point 0.4 into surface area. Surface area would be 4 pi 2r square. Okay, so surface area, sigma epsilon A T raised to power 4. So this is the rate at which we are losing power because the surrounding is at 0 Kelvin. So there is no radiation coming from the surrounding which this sphere will absorb. So there is no absorption taking place. So this is the rate at which we are losing power. So this should be equal to minus ms dt by dt. So this is the equation, and from here we have to solve. So let's before substituting number, let's see what we can get rid of, and let's get rid of those things so that we can reduce our calculation. So mass will be written as density into volume. Now volume will be written as 4 pi by 3 and then outer radius cube of that minus inner radius cube of that. So and then s into dt by dt. So this is what we have to finish. So this will become rho into 4 pi by 3 and then 8 minus 1, that is 7. So 7 into r cube into s into dt by dt. Okay, this is what we are getting. On this side, we have sigma epsilon 4 pi and then 4 r square t raised to power 4. Let's see what we can cancel out. So whatever I can cancel out, I'll do it in red color. So clearly this r square will get cancelled and we will have only r left here. Okay, so only r will be left here. The 4 pi thing will totally, we can cancel it out. I don't see anything else getting cancelled. So let's do the calculations now. So sigma epsilon, and then a 4 is left there. Okay, then definitely there is a 4 here. So I've taken care of this, I've taken care of this, I've taken care of this. T raised to power 4 is left here, but that will go in the integration. So let's keep it out. So on the left hand side, I've copied down everything. Now row, okay, I have to copy this 3. This 3 will come in this numerator, so I've taken care of that also. The 7 will come here in the denominator. I've taken care of that. There is an R also, so R I will keep. Okay, so I've taken care of that. There is an S. Okay, that's fine. Now we are left with minus dt by dt. Okay. So what I'll do, I'm going to calculate this value first. Okay. Um, let's do that. Okay. So let's do it here. Okay. We need some space. So 3 into sigma. Sigma was 5.6 into 10 raised to power minus 8. That was so, and then epsilon was 0.4, and then we have another 4 present here. Okay. Divided by density. How much was density? Density was 9,000. Okay. I'm substituting everything in SI units. So density was 9,000. And then we have a 7 here. And then we have R. So that is 3 into 10 raised to power minus 2. Okay. Again, I substituted it in meters. S is given to be 3,000. Again, everything is in SI units. So we are fine. Okay. So this is what we have to calculate. And rest we have to do the integration. Like let's get this number, or maybe you can, if you want to leave it like that, maybe you can leave it like that, or maybe let's do the integration here also. Let's see. So I will bring dt here and then minus dt by t raised to power 4. So when I integrate this, okay, when I integrate this on the left hand side, it will simply be delta t, and that is what we are trying to find out actually. Okay, so This is what we are trying to find out. On the right hand side, integration will turn out to, let me do it here. So this will become minus 1 upon t raised to the power minus 4, so minus 3. It will become t raised to power minus 3 divided by minus 3. Yeah. And then 1 upon t cube. And then temperature change from 1000 to 500. Okay. So this I will do it here. So this will become minus minus gets cancelled 1 upon 1000. And then 1 upon 500 cube. So I will bring out 10 raised to power 6 and 125 common. So this will become what? 10 raised to, so this 100 I took out, 5 I took out, so this will become 1 minus 1 upon 8 is what it becomes. Okay. Now I think it's time that we do some calculation and reduce what looks like a very long expression. So let's do that now. Okay. So let me start by cancelling this 3 with this 3 and this 3 with this 3. So we have 1,000 here. Okay. So three zeros, additional three zeros, they get cancelled with this. Okay. So this is gone. Okay. Next, what I can cancel is I can cancel this 7 with 5.6 to make it zero point 0.8. Okay. So this will become 0.8. Okay. I think that's enough for now. Okay. Yeah, I think that's enough for now. We have to calculate delta t, right? We have to calculate delta t. So I'll keep delta t on this side, and on the right hand side, what we have is 1 upon 125 into this will become 8 minus 1, 1, 8 minus 1, 7. So 7 by 8. Okay. Now in the denominator, we have a 9 left, so that will come. We have a 10 raised to the power minus 2 left. Okay. So 10 raised to the power minus 2 and 10 raised to the power minus 8. So that is 10 raised to the power minus 6, which will come here and become 10 raised to the power 6. So I've taken care of that. Zero point 0.8. Okay. So this will become 0.8 into this I've taken care of into 1.6. 1.6. Okay, so I've taken care of this. So is there anything left here? I don't think so. 9 has come already. Yeah, I should have removed it. 9 I copied. So yeah, I think when I finish the calculation here, I should get the answer. So as you can see, guys, that it was indeed a very calculation intensive question. Okay, so what am I looking at right now? Okay. So let me first take care of the powers of 10. So if I remove this dot, if I remove this dot, let me change the color of the pen again. So if I remove this dot, if I remove this dot, and so this becomes 10 raised to the power 4. Okay, let me check for the other numbers now. The other numbers are 7 into 6. Okay, just a minute, guys. Oh, I think there is a small mistake. I think it will not get cancelled. It will get added up. Okay, so 10 raised to the power 8. And let me do one thing. Let me, okay, let me write it like this right now. So then it becomes 7 into 9, 7 into 9 divided by 125 into 8 is 1,000. Okay, 125 into 8 is 1,000. So I've taken care of that. And then we have 8 into 16. Okay, now if you notice this, this becomes what? 10 raised to power 5. Okay, this is 10 raised to the power 5, and this is what? 63 by 64. Okay, so 63, not 64, sorry, 63 by 64 into 4. Okay, yeah. So what I see from here is again a slight error. This would be 2, 64 into 2 into 2. Okay, so this is less than 1. This is a little bit less than 1. So whenever we do it with divided by 2, we will get something which is less than zero point 0.5. Okay, so something which is less than zero point 0.5, and we have 10 raised to the power 5 here. So we are expecting 10 raised to the power 4 into something which is slightly less than 5. It will, all right. So option D looks like the right answer. All right. So guys, here keep in mind that these two numbers are significantly different, and then in the four option we have different powers also. So I did not do the exact calculation because I was not needed to. I paid attention to the power of 10, and then I paid attention to the numerical value, like in what range should I get the numerical value, and that helped me to avoid a little bit of calculation in the end. Apart from that, it was a very calculation intensive question. Okay, now we go to question number 9. It says a cavity of radius r by 2 is made inside a solid sphere of radius r. The center of the cavity is located. So, guys, as you start reading this question, it is imperative that you start making a figure also because this question it's prone to error if you don't make the figure correct. And so let's say if this is the sphere and this has a radius r. Okay, this has a radius r. So we made a cavity of radius r by 2, and the distance, the center of the cavity is located at distance r by 3. So I'll change the color. So from here, if this is R, I will break it into three parts. Okay, so this is R by 3. So somewhere here, okay, this is R by 3. So this is the center of the cavity. So when I draw the cavity, cavity has a radius of R by 2, which is more than R by 2, 3. So the cavity should look like this. I hope you get this. Try to make the as accurate figure as you can. So this distance is r by 2. Okay, and so we now know that this is the portion which is occupied by mass. Okay, this is the portion which is occupied by mass. Another question is asking, there is the gravitational force on a particle of mass m at a distance r by 2 from the center of the sphere. So center of the sphere is this point. From this point at a distance r by 2 on the joining both the on the line joining, it should be on the line joining. Okay, both the center of the sphere and the cavity. So on this straight line, opposite to the center of the cavity. So here. So this distance is r by 2. Okay, this distance is r by 2. Okay. So what I'm going to do, m indicates the mass of the complete sphere. So if this sphere would have been complete, if this sphere would have been complete, the gravitational field at this point would have been g capital M r by 2. That is distance from center divided by r cube. Okay. And now we will subtract the contribution from this removed portion. Now, what is the mass of the removed portion? So if it has a radius which is half of the original sphere, okay, then its mass will become 1 by 8 times. Okay, I hope you understand this because r cube is the ratio in which the mass comes. So the mass will become, so now this is a sphere of mass m by 8, and from the center of this to the point here, the distance is r by 3, this distance was r by 3. The distance between the two centers, I'll mark it in maybe white color. So from here to here, the distance was r by 3, and from here to here, the distance is r by 2. We need the distance from the center of the cavity, so that distance will become r by 2 plus r by 3. So it will become 5r by 6. So we are going to write minus g into mass of the cavity, the divided by 5r by 6 square of this, and this entire thing multiplied by small m will give us the answer. So let's finish this calculation now. So from here, we can take out gm by r square as the common quantity. And from the first term, we will have a half left. And from here, we will have 36 divided by 8 into 25. Okay, so this is what we are going to have. Now we have to finish this calculation. So 4 times of 9, 4 times of 2. I'll take 2 out as the common quantity. So gmm by 2r square, and then 1 minus, now 9 by 25. 1 minus 9 by 25. So this will become 9, 25 minus 9 is 18. Okay, so this will become, no, 16. 16. So 16 by 25 into 1 by 2 gmm by r square. So this becomes 8 by 25. 8 by 25 mg, because this gm by r square is small g. So 8 by 25. So option C is the right answer here. All right, students, so that was question number 9 for you. Now we go to question number 10. That's a pretty easy question. It says that there is a uniform disk of mass m. Okay, there is a uniform disk of mass m, and this disk has a radius r. Okay, it's rotating about its axis, which is fixed and vertical with a constant angular velocity omega. Four objects, each of mass m, are kept gently on the opposite from two perpendicular diameters. So this disk will have one diameter like this, the other diameter like this. And what we have done, we have planted four particles here gently. That means without exerting any, any pulse. And that, because of that, the omega will change to a certain value. So, we know that we are going to use angular momentum conservation here. So initially, the disk had moment of inertia of mr square by 2 about its axis of rotation. So this becomes the angular momentum. Later on, the moment of inertia becomes m by 2 r square plus each of these particles will have a moment of inertia of mr square, and there are four such particles. So this into omega prime. So you finish this calculation here, and what you are going to get is m divided by m plus h small m into omega. So that is going to be your answer. So capital M divided by, so option D looks to be the right answer here. So that was question number 10 for you. Next, we go to question number 11. It says there are three concentric metallic spherical shells of radius so much, and each has been given a charge q. So I'll draw the inner and the outer, both surfaces of the shell. So this is the first shell of radius r. Then this is the next shell. This is the next shell of radius 2r, and then this is the next shell of radius 3r. Okay, so this is it. Okay, now understand this. When we have given the same charge q to all the spheres, the innermost will have zero charge on its initial internal on its inner surface, because inner surface can have charge only when there is something else kept inside it. So there is nothing kept inside, so this is zero. So the q will appear here. Now, by the same logic that I was just giving, if the outer surface of the innermost sphere carries charge q, then the inner surface of the middle shell will have a charge of minus q. The total charge should be q here, so 2q appear. Similarly, minus 2q here and 3q here. So the charge density on this one, is q upon 4 pi r square. The charge density on the outer surface of the middle shell is 2q divided by 4 pi 2r square, and on the outermost it is 3q divided by 4 pi into 3r square. So this becomes 1 is to 1 by 2 is to 1 by 3. or 6:3:2? Okay, so option D again is the right one. So that was question number 11. Next, we go to question number 12. It says current flows in a uniform wire of diameter D when the mean electron drift is V. Now, what is mean here? Mean means on an average, like all the electrons, we are taking the average of those. So the same current flows through the wire of diameter D and the same made of the same material. So material is same. Okay, guys. So current can be written as J into A, and J is N E VD, okay, and EVD, and area would be written as pi d square by 4, where d is the diameter of the wire. Let's understand this. So in the two situations, we have used the same wire. Because we have used the same wire, the number of free electrons per unit volume will be same. So N will not matter. It is same in both the cases. E is same in both the cases. Pi is same in both the cases. 4 is same in both the cases. So current is proportional to the product of VD into D square. All right, and current is same in both the cases. So the drift velocity in the first case into the diameter square of the first case should be equal to the drift velocity of the next case into the square of diameter of the next case, that is d by 3 square of this. So from here, V dash is 9 times of V. So option C is the right answer. So option C is the right answer here. Now we come to question number 30, which is actually an interesting question. Some of you may have got it wrong in the exam. It says a parallel plate capacitor has square plates. Okay, so this is the square plate of the parallel plate capacitor, and then I'll draw the lower plate also somewhat like this. Okay, and we have filled it with the dielectric layers. Okay, so one of the dielectric layer is like this. Okay, so it occupies half of the entire volume between the plates. All right, it has a thickness of d by 2, and then there are another two layers which occupies one fourth of the entire volume available. Okay, they occupy one fourth of the entire volume available like this. Okay, so this is the situation, guys. Okay, this is the situation. So in this question, I hope you get the figure now. Okay, so there are a total of three slab, one this one and two this one. So without any dielectric, what I will write capacitance as area of the plate into epsilon naught by d. Now, if I consider only this portion as one of the capacitor, okay, like one plate here, the other plate here, then the capacitor would be area of the plate will become a by 2, then epsilon naught, then k, whatever it is. Let's say it's k1 maybe, or whatever k. The print is very small, divided by d by 2. So it ultimately becomes k times of C naught. Okay, so what I'm going to do, I'm going to consider this combination as four capacitors. Okay, four capacitors, 1, 2, and 3, and 4. 3 and 1 are connected in series. 3 and 1 are connected in series. 4 and 2 are connected in series, and their combination is connected parallelly. This is what I'm going to assume. Okay, 1 and 3 are connected in series, 2 and 4 are connected in series, and their combination is connected parallelly. Most of the students have a question at this point. The question is that why can't we consider 1 and 2 parallel, 1 and 3 and 4 parallel, and then their combination to be connected in series? The answer to this is, guys, we can consider two capacitors to be connected parallelly only when we can ensure that the same potential exists on both the plates of the capacitor. Now, here we have a metallic plate that will ensure that the potential on one side of this capacitor and the potential of this one, of this capacitor, and the potential on one side of this capacitor, that is same. But on here we do not have any metallic plate to ensure the same. So we can't consider the first capacitor and the second capacitor to be connected parallelly. We can't do that. All right. So that is the answer to if anyone was having that doubt. So now, if this, if this and this they are connected in series, then we will write 2 C naught because the dielectric constant is 2 into 4 C naught because the dielectric constant here is 4. Okay, divided by 6 actually, 6 C naught. Okay, 6 C naught. Similarly, for this combination, we are going to write 6 C naught, the dielectric constant is 6, again, 4 C naught divided by sum, which is 10 C naught. So this simply becomes what? This is 4 by 3, so 1.33 plus 1.33 plus 2.4 C naught. So it becomes what? 3.7, around 3.7 C. So option D is the right answer. So that was question number 13 for you. Next, we move to question number 14. That's a very interesting question, guys. Most of, like many of the students may have left this question in the exam because they may not be knowing the theory of this question. And if they were knowing the theory of this question, then they would have, most of them would have thought that this is a very, very calculation intensive question, because those of the students who have studied this topic, they would know that a lot of calculation needs to be done. The point here is that if you know how the electron, how the positive charge particle is going to behave, you don't have to do any mathematics. You can use elimination to get rid of the answer. So let's answer this question qualitatively instead of going into the math. Okay. If this were an advanced level question, then the options would have forced us to do the mathematics, but no, it is a JEE main level question. So it may look difficult, it may look calculation intensive, but it is not. Okay, let's see. So Let's say this is x-axis, this is y-axis. According to the information given in the question, what is happening here? It says that there is a positive charge q mass m released at origin. So we have released it. That means the velocity can be considered as zero. There are uniform magnetic and electric field in space. Electric field is in the j direction, so in this direction, and magnetic field is in the k direction, so it is outward. So I'll make dots. Okay, so that is how the magnetic field is. Now, when you release this particle, at that very moment, there is no magnetic force acting on the particle because the velocity is zero, but the electric force is still there. So the electric field force will cause this particle to begin its upward motion. Now, as it begins its upward motion, it acquires some non-zero velocity. Magnetic force comes into picture, which is still very small because the velocity is very, very small, but it begins to act in, towards right. So it will start deflecting the particle off the y-axis. Okay, so the particle will begin to deflect, and at the same time, the electric field is increasing the speed. Mind you, magnetic field cannot increase the speed. So the magnetic field will continuously keep on deflecting the particle. So the particle will go like this. And when the particle begins to, it continues to get deflected because of the magnetic force, it again reaches y-axis. Now it can't cross the y-axis. Keep in mind. Why? Because here the kinetic energy was zero. Magnetic force is not doing any work. So when the particle returns back to the y-axis, the total work done by the electric force has become zero. Okay, because electric field is in y direction, the displacement in y direction has become zero. Electric field force is a constant force here. So the displacement has become zero. So the work done has become zero. Magnetic force is not doing any work. So the change in kinetic energy should be zero. So the particle will come to rest here. Okay. And therefore it will not go below the y-axis. Sorry, the x-axis. Cannot go below the x-axis. So whatever has happened, the entire thing will then get repeated. So although I don't know the shape of this trajectory, whether it is a circle, ellipse, hyperbola, or something else, it's a cycloid, by the way, but that we have to prove. I'm telling it by knowledge. But even if I don't know that, I know that it is going to do a periodic motion like this, something like this. So based on this, let's try to eliminate the option. So we want to know the y coordinate of the particle. Now, one thing I'm very sure that is given in the question, that at t equal to zero, the particle was at the origin. So if I put t equal to zero, I get a zero here. So this is fine. If I put t equal to zero, I don't get a zero here. So this is certainly wrong. Okay. Similarly, if I put a t equal to zero here, I don't get a zero, so this is certainly ruled out. If I put a t equal to zero, I do get a zero. So as of now, A and D option, they are in contention. One of them is wrong, one of them is right. Based on whatever I have judged right now, I can see that the y coordinate cannot become negative. Okay, but if I go with this, at some time, the y coordinate will become negative. So even this is ruled out, and therefore option A is the only one that is correct answer. So understand this, guys. It might have looked very difficult, but if you go with elimination, it wasn't difficult. All right. Whatever time I took it to explain it to you guys. Otherwise, this question was to be done very easily. Now, this is something that is very easy for you guys. You know that in an LC oscillation, the omega is given as 1 upon root LC. Now, this question is just asking you to calculate the equivalent value. So, L equivalent, these two are connected in series. The inductors, they get added up like the resistors. So, it is going to be 8L. The capacitors, so these two are connected parallelly. Their combination will become 3C. 3C and 6C, they are connected in series. So C equivalent will become 6C into 2C by 8C. Um, Sorry, 3C here, 3C and then 9C here. So this will become 2C. So omega will become 1 upon root of 8 into 2, that is 16. 16 LC, so 1 upon 4 root LC. This is omega, and frequency is omega by 2 pi. So option B should be the right one here, as we can check from the answer. So option B is indeed the right one. Now we go to question number 16. Now again, this is again, you need to make good figure and you need to do a bit of calculation to get this question right. So what this question is telling, I'll need a bit of figure, a big figure. So let me create some space for myself. So what is happening here is that let's say this is the interface. This is the interface. So light starts traveling from some point here, which is at a height of 0.4 a from the interface. And then light goes like this, and then it bends and travels like this. But this particular ray, which is making an angle of 37 degree here, it becomes tangent to a circle. Okay, let me draw the circle. Please excuse me if my circle doesn't look like a circle, if it looks like something else. So it becomes a tangent to a sphere like this. And the radius of the sphere is A. Okay, so this distance is A. This will be 90 degree because this yellow line is the tangent. Okay, and again, this distance would be A. Okay, so if I extend this refracted ray backwards, it will strike somewhere here. Let the height of this point be y, and not only that, if this angle is 37 degree, then this angle is also going to be 37 degree. Let's name some points. Let's name this as maybe x. Let's name this as y. Let's name this as z. Let's name this as t. Okay, so notice that triangle T, let's call it C. triangle TCZ is a right angle triangle. Okay, triangle TCZ. And if I write the value of sine 37 in this triangle TCZ, then this length CZ will become the perpendicular. Okay, and TC will become the hypotenuse. So A divided by this entire length is y plus A. Okay, so from here we'll be able to find the value of y. Sine 37 is 3 by 5. So this becomes 5A is equals to 3y plus 3A, or y is equals to 2A by 3. So we now know the value of y, okay, which we are going to use when needed. Okay, next, uh, okay, what my intention is, we have to find the value of the refractive index. So I plan to use uh, Snell's law. To use Snell's law, I need the angle of incidence. So this is the angle that I'm looking for, and the same angle would be present here. Okay. So I can see from here that tan I, if I try to write tan I, then I really need this length. Okay. And then divide. So xy divided by 0.4a. Now, how much is xy? To calculate xy, I'm going to make use of triangle TXY. Okay. So let me call this as equation one. So TXY, in triangle TXY, tan 37. See, tan 37 is 3 by 5. 3 by 4 will become xy divided by this y. Y is 2a by 3. So xy becomes equals to how much? 2a by 3 into 3 by 4. I think it becomes a by 2. It becomes a by 2. Okay. So I'll substitute it here. Tan I is how much? Okay, let me create some space by erasing this equation number one. So tan I is 0.5a divided by 0.4a. So this becomes 5 by 4. So this is tan I. Okay, now if tan I is this much, how much is sin I? Sin I will become 5 divided by root of 25 plus 16. That is around 41. So this is sin I. And now you are in a position to use the Snell's law. So 5 upon root 41 is equals to mu into sin R. R is 37 degree. So sin R is 3 by 5. So mu is 25 divided by 3 times of root 41. So this is close to what? 25 upon 3. Root 41 is close to 6 point, let's say 4. Let me just check on that. All right, so 6.4 it is. So this is what? 25. 25 divided by around 18 point something. So 25 around 19.2 actually it is. So this ratio, all right, this ratio looks closest to what? It looks closest to 1.3, and therefore option B would be the right answer here. So again, this was another calculation intensive question. All right, but I hope you got it right. I hope you understood this question. Question number 17. It's an absolute gem of a question. It's absolutely fabulous. I can bet on this that most of the students would have either skipped this question, or they would have spent a lot of time in trying to do this question correct. Okay, so I'll tell you. Let me first tell you what is the trick in this question. So the trick is that, let's say in hydrogen atom, if a transition has taken place from n1 orbit or n2 orbit, like a transition has electron has moved from n2 orbit to n1 orbit, and it has given a photon. Okay. Now the same photon, which means the energy, the a photon of same energy, would be given by another atom of atomic number Z, another hydrogen-like atom of atomic number Z, if the transition happened from Zn1 to Zn2. That's right, guys. So, for example, if in hydrogen a transition took place between the second and the first orbit, so that gives us a photon of 10.2 electron volt. Now, if I ask you that how can I get 10.2 electron volt from, let's say, helium plus? So the atomic number of helium is 2. So multiply both these numbers with 2. So in helium, a transition between 2 and 4 will give me a photon of energy 10.2. Okay. What about lithium? Lithium plus 2, because hydrogen like it has to be. So lithium plus 2. In a lithium plus 2, the same photon I will get if I multiply both these numbers by 3. So 3 to 6 will give me a photon of energy 10.2 electron volt. All right. So that is the final. So it says that second line of Lyman series. So second line of Lyman series is a 3 to 1 transition. So is absorbed by a hydrogen-like atom in the fourth excited state. So there was a hydrogen-like atom. Okay, there was a hydrogen-like atom, and that atom was in the fourth excited state. Now remember, fourth excited state. So that is fifth orbit. So electron was in fifth orbit, and it absorbed this photon, and it moved to some another orbit. So if it has absorbed this photon and moved to another orbit, then it means that the transition energy of this transition should be same as the this one. So what I was saying, that this photon should be same as the photon that we get from hydrogen. So the photon that we get from hydrogen from a 1 to 3 transition, we are getting the same photon from another element when the transition happens between 5 and some other orbit. So that other some other orbit needs to be 15, and the atomic number of this needs to be 5. Okay, so N is 15, so this is ruled out, this is ruled out, and atomic number needs to be 5, so boron plus 4 is the right answer. So this is how you could have done this question, students. Other than this question was a really difficult question. Okay, now we come to question number 18. Okay, let's see what is there in this question. So this question says, when a monochromatic source of light is at a distance of, okay, photoelectric cell. So basically, there is a target and light is incident from, let's say, a source, and the distance of the source was 0.2 meter, let's say. Okay. Um, so, guys, what happens, like this source must be having a power P. So the intensity or the energy reaching this plate would be given by P divided by 4 pi r square. That would be the intensity multiplied by area. Okay, and this intensity is it's proportional to the number of photons. Okay, so the intensity hitting this plate will be written as number of photons hitting per unit area into the energy of the of photons. So this is how. Number of photons. Yeah, that would be the intensity. Okay, so the photocurrent is proportional to this number. So what we can see here, if I just shift this bulb to another distance, I've not changed the frequency, I've not changed the area, I've not changed the power. The only thing that I've changed is R. So the number of photons or the number of electrons, or the number of photons hitting this target, okay, that is proportional to 1 upon R square. So if I make R four times, if I make R four times, then this N will become uh, 1 upon 16 times. And therefore, the current will become 1 upon 16 times of the previous value. So the current will become 3 milliampere. Okay, so this is right, and the others are wrong. Okay, the stopping potential depends on the frequency. It remains unchanged. It was 0.6 volt earlier, so it will continue to be 0.6 volt. So this is how you could have done this question, everyone. Now, question number 19. Again, a little bit of calculation will be needed here. It says two radioactive material A and B have decay constant of this much. Okay. Initial activity has same. So let's say we have a sample A, we have another sample B, and we have N naught A atoms of A, we have N naught B atoms of B initially. Now, the activity of A would be given by lambda of A, that is 10 lambda naught into N naught A. And the activity of B would be given by the lambda of B, which is lambda naught into N naught B. So from here we get a ratio of N naught B upon N naught A, N naught B upon N naught A as 10. Okay, so this is an equation. Now the question says that ratio of number of undecayed nuclei of B. So the number of undecayed nuclei of B would be given by initial number of B into e raised to power minus lambda of B into T. Similar number for A would be given by initial number of A into e raised to power minus lambda of A, which is 10 T naught, 10 lambda naught into T. And now this ratio, okay, this ratio becomes how much? This ratio is e raised to power 3.3. So notice this, that n naught b upon n naught b. We need this ratio now, okay, and we calculated this ratio to be 10. So 10 into e raised to power, when this goes into the numerator, it becomes 9 lambda naught t is equals to e raised to power 3.3. Now we can take log of both the sides. So ln 10 plus 9 lambda naught t becomes equals to 3.3. Ln 10 is 2.3. So 9 lambda naught t becomes equals to 1. Okay, so T is 1 upon 9 lambda naught. So option B is the right answer here. So that was question number 19 for you. Next, we go to question number 20. It says ball A. It collides with another identical ball at rest, and once it happens, then the velocity of B is 4. So if the velocity of A is V, this has 4V. So from momentum conservation, these balls are identical. So from momentum conservation, we will write mv naught is equals to mv plus 4mv. So it becomes V is V naught by 5. So the coefficient of restitution is velocity of separation, that is 4V minus V upon velocity of approach, that is V naught. So this becomes 3 into V. V is V naught by 5 divided by V naught. So 3 by 5 is the right answer. Pretty easy question, I would say. Nothing much in it. Okay, you just do whatever is written in the question and you will get the answer. So that finishes our SCQ section, and now we move on to the numerical section. So let's see what the question says here. A balloon is going upward with a constant velocity of 25 meter per second. So there is a balloon, okay, a hot air balloon maybe. This is going up with a velocity of 25 meter per second, and when it is at a height of 120 meter, okay, when it is at a height of 120 meter, we dropped a stone. Now, key point to remember here is that when you release something from a moving vehicle, the initial velocity of that thing is considered to be equal to the velocity of the vehicle. So the initial velocity was 25 meter per second. So it goes up, it comes down, it hits the ground. And during, we have to find out the time. Now, during this entire course of motion, the displacement would be this. If I consider upward as positive, I will say that the displacement is downward, which is negative. Remember, displacement doesn't depend on the path taken. It only depends on the initial point and the final point. So the displacement is minus 120. So I'm planning to put values in this. S equal to ut plus half at square. So F is minus 120. U is in upward direction. So 25 into t, and then half. Acceleration is in the downward direction. So minus 10. The question says to use 10 into t square. You solve this equation to get the answer. When you solve this equation, I think it's going to be a quadratic. You're going to get two answers or two equations. Okay, let's finish it. So this will become what? I can cancel out 4 from 5. Um, so this becomes minus 24 is equals to 5t, and then 5 gets cancelled, 5, and this becomes t square. So it becomes t square minus 5t minus 24 equal to 0. So from here, the value of t comes out to be 8 and minus 3. Okay, so these are the values that we're getting. So we'll reject the negative value and we'll take the positive value. So 8 is going to be the right answer. Now we move to question number 22. It says two identical containers with frictionless pistons contain the. So there are two identical pistons, identical containers. Okay, they contain frictionless pistons, same ideal gas at the same temperature at the same volume. So because the volume is same, that means the area is same. Identical containers, the height should be same. Therefore, the volume will be same. The mass of gas in A is 2 grams. So here we have 2 gram of mass, and each cylinder is now allowed to expand isothermally to the same final. So both of them have been. So guys, let's try to understand. Their volume is same, their temperature, same ideal gas, same temperature, volume is same, everything is same. Okay. Um, Okay, the changes in the pressure. Now, the changes in the pressure is different. That means the initial pressure should be different. Okay, the quantity of the gas should be different. Okay, like if I check PV equal to nRT, we are saying that V same, T same, and P is not yet same. So N has to be different. In other words, mass needs to be different. N can be written as mass upon molar mass. So the mass of the gas was definitely different. We don't know how much mass was present here. Okay, now understand this. If you are doing isothermal expansion to double the volume, then it means that the pressure will become half. So if the pressure here was P1, the final pressure will become P1 by 2, and therefore the change in pressure will be P1 by 2, which is delta P according to the question. Okay, similarly, if the pressure here initially was P2, again it will become half, it will become P2 by 2. So the difference would be P2 by 2. And according to the question, this is 1.5 delta P. If I divide them, I get P1 by P2 is equals to 1 upon 1.5, that is 2 by 3. And the pressure is proportional to the masses. So the ratio of the initial pressure should match with the ratio of the initial masses. So M1 by M2 should be equal to 2 by 3. Or in other words, M2 should be equal to 3 by 2 into M1. M1 is given to be 2 grams. Okay, M1 is given to be 2 grams. Where it is, somewhere it was, yeah, here, 2 grams. So if M1 is 2 grams, then M2 will become 3 grams, and that is what we were supposed to find out. So the answer would be 3. Okay, that is question number 22. Now we move to question number 24. It says the uniform surface charge density sigma is given to the 1/4 of an infinite non-conducting plane in the first quadrant. So guys, if we have another identical sheet here and here and here, so that would make it a complete sheet of density sigma. And now the z-axis would look like this. And we have a point here, we have a point here. The distance between these two points is 2d. Okay, the distance between these two points is 2d, and this distance is there in the uniform electric field. So the potential difference would be sigma by 2 epsilon naught, that is electric field, into the distance, which is 2d, and the angle between electric field and this direction is 0. So cos 0, which is 1. Um, Okay, now this is because of the four sheets. Okay, so this potential difference is result of four identical sheets. So the contribution from one sheet would be sigma d by 4 epsilon naught. And therefore, the value of A would be 4. So 4 should be the right answer to this question. And now we move to question number 24. It says rectangular loop of side. Okay, so there is an xy plane. This is x-axis, this is y-axis. A rectangular loop is kept somewhere in this plane. Okay, the sides are 2 and 3. Actually, I have drawn it, otherwise. Anyways, doesn't matches with the dimension. It looks 2 is more than 3, but let's ignore the fact. Now we have a magnetic field. Some of it is in I direction. So keep this in mind that whatever component is there in the I direction, it is not contributing in the flux through this loop because it is parallel to the surface of the loop. Even this is not contributing. So the Y component is also not contributing. So this is not contributing. This is contributing, and therefore the flux and this is not constant, but this is uniform. It is same throughout the space. Okay, so the flux will be given by 6 into 10 raised to power minus 4 meter square. This is the area of the loop. 2 into 6, 2 into 3, 6 centimeter square has been converted into meter square, multiplied by magnetic field, which is 50 into t square. So this is the flux. So the rate of change of flux is 300, 6 into 50, 300 into 10 raised to power minus 4 into 2t. And now you put the value of t as 100 seconds. So this becomes 600 into 10 raised to power minus 4 into 100. 6 looks to be the correct answer. Yeah, let's check. Yeah, 6 is the right answer, everyone. And that brings us to the last question of this test. It says in a Young's double slit experiment, fringe width was something. So we did the experiment once and we got some fringe width. Okay, we got some fringe width beta. Beta is given by d lambda by d. So this is the fringe width. Okay. Now what is happening that we have not disturbed the setup. So we have not changed this distance. We have not changed this distance. We only changed the medium, because of which the wavelength will change. Wavelength will change to lambda by mu, which means that the fringe width will also become beta by mu. So 0.8 divided by 4 by 3, that is 0.6 mm, or k is equals to 6. So k equal to 6 would be the right answer to this question. And that brings us to the end of the discussion of physics section of this test paper. I hope you enjoyed the paper, guys. The paper was made a little bit above the JEE main level. We were trying to select or give scholarship to the students who are preparing for JEE Advanced, and therefore a little bit of taste of JEE Advanced was needed in this paper. But of course, if you have scored good in this paper, that will really boost your confidence for JEE main also. All the best. Hope to see many of you in Eklavya batch. And if you are preparing for JEE Advanced, it is imperative that you join Eklavya. Take care, students. Bye bye.
Hello, my dear students. So let us now discuss your next JMMT, that is JEE Mains mock test, right? So I am sure you all have been giving the regular mock test and analyzing your performance in each one of them. So let us start with the very first question from chemistry in this JMMT. So guys, this question was already asked in one of the previous mock tests in a numeric value questions, right? And in that paper, I assume most of you will not be able to answer it correctly, but after giving that test, you should know the answer, and that is being checked in this question again here, that did you analyze the JMMTs or the mock test that you have been giving, right? So let's check. CHCl3 on Ag, that will give you, of course, alkyne, right? Acetylene will be formed here. So the product, and I'm sure this is hydrocarbons reaction from NCRT, this is the product, right? Which on hydration in the presence of HgSO4 and H2SO4. So water addition will be there and you get this aldehyde. So B is your this aldehyde. Addition of water, enol will be formed, which will tautomerize to give this keto form, or you can say aldo form, right? So now you have this acetaldehyde with excess of HCHO. This is what I was telling you, it was asked in your previous JMMT. So there I explained it. We have excess of formaldehyde, the reaction of formaldehyde with acetaldehyde, excess. Of course, you can assume with NaOH it will go, yes, a very common aldol condensation, right? So, of course, this will form carbon ion, and aldol condensation between the two aldehydes will take place 3 times, and then last step is followed by, because there will be no acidic hydrogen left, then the last step is Cannizzaro. Yes, 3 times aldol followed by Cannizzaro, and the final product that you get, that will have 4 alcoholic group. This I have already explained in previous JMMT, and those who couldn't solve it this time also, high alert guys, high alert. Please see here. So the A will be acetylene, of course, that will give you acetaldehyde, and this is the final product that you will get with 4 alcoholic group after doing aldol condensation thrice and followed by the Cannizzaro reaction, guys. So this is the product that you'll get, and which has OH, 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 4 OH group here, right? So this is question number 1, and I hope you did it right. D donkey is the answer. Next question, let's move on to the next question. Easy question on stoichiometry. You can say an iodine solution 150 ml was divided into 2 parts. One part reacts with 15 ml of sodium thiosulfate. So the iodine reaction with sodium thiosulfate, and the second part was added to NaOH. So NaOH was reacted with that. Excess base requires 10 ml 0.3 molar H2SO4 for complete neutralization. Calculate the molarity of initial I2 solution. So basically what you are supposed to calculate the molarity of initial iodine solution, that is the initial moles of iodine solution divided by the total volume. The total volume here is 150 ml, right? Yes, we can convert it into liters also, whatever you feel like, right? So this is molarity. Now orally also you can do. Iodine reacts with thiosulfate, this is the equation. Iodine reacts with NaOH, this is the reaction. I have just balanced it, nothing else I did, right? The way we do in stoichiometry, I just balance the reaction. So guys, let's see how much hyper solution was consumed. 15 ml, and so molarity into volume will give me the moles, because I'm taking the volume in, you know, milliliters. 15 milliliters, right? And 0.4, right? So that means I'm taking the volume in milliliters, I will get the millimoles. So how many millimoles molarity into volume? How many millimoles of thiosulfate? 6 millimoles of thiosulfate was consumed to react with I2. So 1 I2 consumes 2. That means how many millimoles of iodine is there? 3 millimoles of iodine is there, which reacted with hypo solution, guys. Got it? Now, the same way. Okay. So, you added, how much NaOH you added? Molarity 0.3, volume is 100. That means 30 millimoles of NaOH, molarity into volume, this millimoles of NaOH were added, right? And out of that, how much is left? That reacted with your H2SO4. So how much H2SO4 was consumed to react with the excess of NaOH? So molarity into volume, again 0.3 mole and 10, that is 3 millimoles of H2SO4 was consumed. That means how much NaOH is left? 1 mole of H2SO4 consumes 2 moles or neutralizes 2 moles of NaOH, right? If 3 moles of 3 millimoles of H2SO4 was consumed, that means how much NaOH it was reacted with? 6 millimoles, right? Yes, so 6 millimoles of NaOH was left after the reaction, which was neutralized by adding H2SO4, right? That means you added 30 millimoles. Out of that, 6 millimoles are left behind after reacting with I2. That means 24 millimoles of NaOH reacted with I2, right? Molarity into volume only we are using. And as per the equation, if 24 millimoles of NaOH was reacted, 6 millimoles of NaOH react with 3 millimoles. If 24 is, that means 12 millimoles of iodine was there. Half. Yes, that is 12 millimoles of iodine was there. So in first part, there are 3 millimoles. In second part, there are 12 millimoles. Total millimoles will be 15 millimoles of iodine. Right? Total from first part and second part divided by the total volume. As I'm taking, the millimoles, I'm taking the volume in milliliters. That will give me the molarity as 0.1. So 0.1 should be the answer. 0.1 molar of iodine. That is the molarity of the initial iodine solution. Pretty simple. Molarity into volume we are using to get the moles, 2 equations. And I'm sure you get it right, guys. So the answer indeed is, you can check, A. So guys, now let us start with the question number 3. Binding energy of an electron in a hydrogen-like system is in an excited state is 3.4 electron volt. Calculate the de Broglie wavelength associated with the electron. So I'm going to use the formula 2 pi r is equal to n lambda. That is the de Broglie's formula. 2 pi r is equal to n lambda, right? So we are supposed to calculate lambda. So I will write n lambda is equal to 2 pi r 0.529 n square by z, right? Yes, angstrom. This is the formula. I just put the formula for radius of nth Bohr orbit here. And of course, this will get cancelled out. So lambda is equal to 2 pi into 0.529 n by z, right? Also, the binding energy is given to us, right? The binding energy is given to us as 3.4. So 3.4 is the binding energy, that is 13.6 z square by n square. So from here I can get the value of n by z as n square by z square as 4 and by z as 2. So substituting this value 2 here, n by z is 2 here, guys. Yes, we get our answer. So here 2 pi is equal to into 0.529 into 2. That will be your final answer of de Broglie wavelength in angstrom, right? Very simple. We just use 2 pi r is equal to n lambda, the equation given by de Broglie for an atom, and also the radius of nth Bohr orbit. Yes, so these two pretty simple formulas, of course, along with the energy formula, the binding energy, yes, that we used, all the basic formulas that we do in atomic structure from Bohr's model and de Broglie equation we used to crack this question. And I am sure you got it right. Most of you should get it right, guys. So the answer after solving, putting the value, is B. You can check here, guys. Done. So 2 pi 0.529 into 2. Now, the fourth question, calculate the minimum mass of calcium carbonate required for the complete decomposition to establish the following equilibrium in 6.5 liters container. So this is the reaction, and also we are given with the equilibrium constant. Kc is here. So Kc is equal to the concentration of CO2 at equilibrium, because CaO and CaCO3 both are solid. The concentrations are taken to be unity. So whatever is the value of Kc, that is the concentration of your CO2 at equilibrium. So 0.05 moles per liter CO2 is at equilibrium. Now because the container is 6.5 liter, so what is the concentration of CO2 in 6.5 liters? So of course, so the concentration of CO2 at equilibrium in 6.5 liter container, that vessel, this was the value per liter, guys. So 0.05, I will multiply it by 6.5, right? So this is for 1 liter and into 6.5. So you will get your answer 0.325 moles in 6.5 liter, guys. Please check. Yes, so these many moles of CO2. So as equation says, 1 mole of calcium carbonate form 1 mole of CO2. So these many moles of CO2 will be formed by these many moles of calcium carbonate. So moles of calcium carbonate is also 0.325, right? And you are supposed to convert it into mass. So you have to multiply it by 100, because 100 is the molar mass for your calcium carbonate. And I'm sure you will get your answer pretty quickly, because you're supposed to calculate the answer in grams, not the moles. Into 100, you'll get your answer as A. Simple, pretty simple. Should be correct again, I'll say, right? So this was question number 4. And I assume that most of you were able to give it right. Okay, now the next question from, I can see, inorganic chemistry. Okay. Now consider the following statement and arrange in order of true or false as given the codes. Okay, fine. So ICl2 negative ClF3 TeCl4, the number of lone pairs of electron central atom. So in first I have 3 lone pairs, 2 bond pairs. So 3 lone pairs. ClF3 it is. This ClF3, guys. ClF3, right? ClF3, that is T-shaped, of course, 2 lone pair. And here 1 lone pair, 4 bond pair. TeCl4, so it has 3 lone pair, it has 2 lone pair, it has 1 lone pair. So of course it is a correct statement. Now amongst NOC2, O2 negative and helium 2 positive, you are supposed to arrange them according to the increasing order of bond dissociation energy. So more is the bond order, more is the bond dissociation energy. They are directly proportional. So let's check out the bond order, guys. So the bond order for NO is 2.5 to 1.5. Please check, guys. I am simply using the shortcut total number of electrons and the bond order shortcut that we always use to save our time, guys, right? So guys, so bond order, of course, more is the bond order, more is the bond dissociation energy. So NOC2 O2 negative, because it has 1.5 and it has 0.5. So this is also correct. Among CO, CO2, carbonate, CH3O is the correct order from the weakest to the strongest carbon-oxygen bond. Of course, so bond order again. So triple bond, carbon-oxygen double bond, 1.3 bond order and single bond. So of course, more is the number of bond between carbon and oxygen, more is the strength of that bond, right? So very correct order, guys, again. Okay, the hybridization of boron in this. So this is the compound. I can see the boron is sp2 hybridized, is same as that of nitrogen. Okay, nitrogen. So both are sp2 hybridized. We can see here both the atoms. This is also sp2 trigonal planar. This is also sp2. So both have the same hybridization, guys. So all the options, all the statements that are given in this question, this are correct. So we'll go with our answer as A. True, 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 true. Please check. I hope you get it right, guys. So the answer indeed is A, right? So let's move on to the next question now. Let's move on to the next question. That is question number 6. Okay. Okay, the surface chemistry question. Molar conductivity of an aqueous solution of sodium stearate which behaves as a strong electrolyte is regarded as varying concentration of sodium stearate. Which of the following plots provides the correct representation of micelle formation in the solution? CNC is marked with an arrow in the figure. So this is the molar conductivity versus the concentration graph, guys. At CMC, critical micelle concentration is that concentration at which or above which the particles, they start just coagulating, they just start combining up to form micelle, right? So of course, at that point or beyond that point, because the particle size increases, they just aggregate to form a bigger molecule. So bigger is the size of the molecule, the movement will be restricted, the mobility is restricted. Hence we can say beyond CMC there is a decrease in the molar conductivity, sudden decrease, because of the bigger size that the particles, they just aggregate, they just coagulate to become a bigger particles, right? They form a missile after CMC or at CMC, right guys? So clearly, like the graph I can say is the first only. So the concentration decreases and there is a sudden decrease after CMC, right? Because the particle size become more because of missile concentration, right? So the initial graph, I hope, because strong electrolyte molar conductivity graph, I'm sure you are pretty much aware of. So the answer should be A. Got it, guys? Yes. Okay. So the next question, please. This is an interesting question, though it is very easy to mark, but still. So which of the following is not correct? Not correct. That you are supposed to calculate. So you can quickly mark the answer, right? Without, putting so much of time in this question. So for cyclic process, delta U is 0, internal energy change is 0, because internal energy is a state function. For a cyclic process, initial and final state of the system is same, right? I will check the B later on. Cp is equal to infinity for water when it is in equilibrium with vapor at 1 atmosphere. Yes, there is an equilibrium with water and the vapor, you can see, right? There's no change in the temperature at that point. So if there is temperature remains constant, that means your heat capacity will be infinite. Yes, so that is also true. For a real gas, the molar internal energy can be given as 3/2R. So guys, it is for 3/2R, we can say it is for ideal monoatomic gas. This is not for diatomic, polyatomic. So when we say the internal energy is 3/2R, that is for 1 mole of monoatomic ideal gas. So this clearly shows, even if I don't know the option B, I can mark that the answer has to be D, donkey, right? Now let's check this also, the part B. It might come again in any of the mock test or maybe your JEE Mains. So let's check it out, guys. So guys, this is the equation, the internal energy equation that you should know. Du is equal to Cv dt plus T dp by dt at constant pressure minus P dV, right? Yes, perfecto. So now, guys, so as you can see here, this is the equation, right? And of course, du by dv at constant T will be this, because the T is constant, so dt becomes 0. So we get this equation, right? Yes. Now this is the equation that we are going to use here. Now we know our, so this is the equation, right? Now we know our van der Waals equation. Van der Waals equation for real gas. Right? This is the van der Waals equation for 1 mole of a real gas, guys. Yep, van der Waals equation for 1 mole of a real gas. We can just rearrange it. So I will get P is equal to RT over V minus B. So I just rearrange it A by V square, right? Now I can do the differentiation of this P with respect to T, because I need this term. dP by dt. I need this term, guys. Yes, so I just differentiate it. Partial differentiation with respect to T. So after differentiating, whatever I'll get, I'll just put it here and see whether whatever is given in the question that matches with my final result, right? So guys, let me do it here only. So dP by dt at constant pressure. So this will become R over, this is what I'll get, R over V minus B, right? Yes. So putting this value R over V minus B here and comparing it with the van der Waals equation. So of course, du by dV by T is equal to A by V square. So this is one, I will put it here, and now this part comparing it with the van der Waals equation, that will be equal to A by V square. So that means du by dV at T is equal to A by V square, guys. Please check. Please check. Yes, this has to be the answer. Oh, this is not P, this is at constant V. Please see this. dP by dt at constant V. we are differentiating at with respect to, T. We are differentiating P with respect to 2, so it has to be at constant V. Got it, guys? Yes. Done? Yep. So this is the final answer. So dP by, we get our answer as such. Yo? Yes? Done? So the B statement also can be verified as a correct statement. Got it, guys? So you can check. So all the options are correct except the D donkey. So that we already got that, right? So the answer is D. Now, 8th question. The radial distribution function is used to determine the most probable radius, which is used to find the electron in a given orbital. So dP by dr for 1s orbital of hydrogen-like species with atomic number Z is given as this. Okay, which of the following is not correct? Let's check it out. So the most probable radius, right? To find the most probable radius, so dP by dr should be equal to the maximum, the maxima. So this dP by dr should be equal to 0 to get the maxima value. The most probable radius, where the probability of finding the electron is maximum. So what I'll do, to get the maxima, I will put dP dr is equal to 0. So very simple. So this entire term becomes equal to 0. So just put it equal to 0. What you will get? You will get 2r is equal to 2zr square over a naught after putting the entire term equal to 0. So let me check. Okay. So from this I can get r is equal to a naught by z. So r is equal to a naught by z for the most probable radius, the highest value, the maximum peak of finding the electron. So r is equal to a naught by z. So guys, okay, for lithium Z is 3, correct. For helium positive Z is 2. Yes, helium atomic number is 2. For radius, for like hydrogen atom, Z is 1. This is also true. All of these are true. So the one that is wrong, but let's check this also. So the incorrect is of course A. At the point of the maximum value of radial distribution function, the probability of finding the electron is greater than 95%. No, it is not greater than 95%, rather it is less than 95%. In fact, orbital is the region, the entire region where probability of finding the electron is this 95%, we can say, but not at the maximum value of radial distribution function, right? So the A statement indeed is a false, incorrect statement. We can go ahead with it. So A, guys, A is not the correct statement. Let's move ahead quickly. Okay, paracresol reacts with chloroform, okay, in alkaline medium to give a compound A. So what is our paracresol? Let's make the paracresol. So the paracresol, guys, is this, right? Now the reaction with chloroform in alkaline medium, the famous name reaction that you should know, Raman-Diamond reaction. So after doing Raman-Diamond reaction, I will get what? I will get CHO at ortho position to that of alcohol. So this is the product after Raman-Diamond reaction, chloroform in alkaline medium. Right? This is my compound A. Okay, adds HCN, of course, carboryl show addition reaction. So this C double bond O, this addition of HCN, right? Which on acidic hydrolysis gives carboxylic acid. Of course, cyanide on acidic hydrolysis forms COOH. And indeed, this is the chiral carbon. The structure of the carboxylic acid. Now, please look for the structure of the carboxylic acid out of all the given options. So that should be your OH, and this chiral carbon should be at ortho position with respect to each other. Though the benzene has 3 substituents, so I cannot use the term ortho meta-para because it is for di-substituted benzene. But still, just to tell the position of this group with respect to OH, I'm just saying that, right? So which option it should match, guys? Of course, A option. You can see they are at ortho with respect to each other. Got it? So pretty simple reactions are being used here to get the correct answer. So the answer indeed is A for apple. Let's move on to the next question. Question number 10. A crystal is made up of particles X, Y, and Z. X forms FCC. That means, so per unit cell we have 4 atoms. X is at FCC, face centered, corners at the, and also at the center of each face of the cube. So per unit cell, I have 4 X atoms. And Y occupies all the octahedral words. So how many octahedral words are formed? Again, 4. The number of atoms per unit cell is equal to the octahedral words. So Y is also 4 per unit cell. and Z occupies all tetrahedral words. So if the N is the number of atoms per unit cell, 2N is the number of tetrahedral words. Yes. So this is our crystal formula. If all the particles along one diagonal are removed, so if I removed the particle along one diagonal, so for X, how many particles? 2 corner particles are being removed, right? And each corner particle is being shared by 8 total unit cells. That means one corner atom is contributing 1 by 8 to the unit cell. So X, 2X are being removed. That means 2 into 1 by 8, that is 1 by 4. Right? That is 1 by 4. Got it, guys? Yes. Now Y. Y are our octahedral word. What are the location of octahedral words? At the edge center and also at the body center. So if I remove the atoms lying along the diagonal, the atom occupying the body center, the octahedral word that is present at the body center, that is also being removed, right? The entire atom. So of course, out of 4, 1 is removed from the octahedral word lying at the body center. Now I have octahedral words. So on one body diagonal, we have tetrahedral words, right? So along each body diagonal, we have 2 tetrahedral words. We have total 4 body diagonals in a cube and total 8 tetrahedral words. So if I remove the atoms lying in the tetrahedral word lying along one body diagonal, that means 2 atoms I will remove from here, right? Got it, guys? Please check. Please check. Fine. So you are supposed to tell the final formula. That's it. So just the final formula, guys. So it is, let me simplify it. It is X 15 by 4 Y 3 Z 6. This is the formula. This is the formula S. Yes. You can take out the 3 common. So it's X 5 by 4 Y 1 Z 2. And now please see how can you further simplify it. Further, you are supposed to simplify it. Multiply by 4, you get X5, Y4, Z8, right? X5, Y4, Z8. This should be the final answer. The answer has to be D donkey. Please check solid state question. Easy question. You should know the locations of tetrahedral and octahedral words in an FCC unit cell, right? So pretty simple, I will say, if you have done the solid state. So the answer was D. Now, what is the type of isomerism represented by the following species? Just have a look. Okay, nice, interesting question. There is one thing that you might get it wrong. You might get it like geometrical isomerism by looking at the double bond, right? This is the one thing that you might get wrong, and I'm sure many of you fell in the trap. Yes. So guys, you can see here geometrical isomerism. You quickly see CH3, HH on the same side, HH on the opposite side. So you'll quickly mark it as geometrical isomerism, but that is not the correct answer because you are supposed to look at the groups. You can see this chlorobenzene is attached to CO here and this chlorobenzene is attached to oxygen here. That means it is showing metamerism. The groups are different. These groups are not same in both the cases. So there is a flipping or the exchanging of alkyl groups across the polyvalent functional group COO. Metamerism shown by esters, right? So they are 2 different groups. So the answer will be metamerism, not the geometrical isomerism, because they are different. They are not same, right? So those who marked the answer as B, sorry to say, you have to be more careful, more mindful while checking the molecules. So the answer that is correct is C. Indeed, I will say easy but a tricky one, right? So let's move ahead, guys. Now the next question from organic chemistry. Okay, so I have a carbonyl compound and addition of HCN that will give us cyanohydrin, right? Adding HCN, cyanohydrin is formed. So the OH and CN, this is my A. Now lithium aluminum hydride, what it will do? It will do reduction. It will convert your cyanide to CH2 NH2, right? Now diazonium salt is being formed. NaNO2 because you have aniline. You can see diazonium salt being formed here, right? Yes, now the C. Okay, the options are a bit different. They're not diazonium salt. So this will get removed. So you will get this carbocation, of course, which can undergo ring expansion. This can undergo ring expansion. You can see it can become 6-membered ring expansion, 5-membered ring. On the adjacent carbon, there is a positive charge. So after ring expansion, this, and again H will be removed, right? This lone pair here and this. So you'll get this as the final product. Got it? Interesting question. You can check that there is no option which has diazonium ion. So of course nitrogen will be released in the carbocation, which will expand. Ring expansion is there, giving you the final product. Got it, guys? So beautiful, interesting question. So answer we mark is A, right? Okay, this is like you are supposed to know. Stachylose is a tetrasaccharide. Tetrasaccharide, 4 sugar molecule saccharides. They are just joined together. 2 galactose, 1 glucose, and 1 fructose. 2 moles of galactose, 1 mole of fructose, and 1 mole of glucose. This you are supposed to know. Yeah? If you don't know, can't do anything, guys. So the various polysaccharides, disaccharides, you should know the units which are joined together, right? So the answer was A. This was also asked in one of the previous JMMTs. It is from qualitative analysis. We discussed it there also, right? If you again did it wrong, then it is very disappointing, guys. You are giving JMMT and you are not learning from the wrong questions. So this is again a check, right? Whether after giving the test, mock test, are you analyzing the question that were left unattempted or that you marked wrongly? So this is from qualitative analysis, though I have discussed it before also. Let's quickly discuss it. So guys, how can you, lead and silver, right? Lead ion and the silver ion, both will form precipitates with dilute HCl. They both will form AgCl. They both belong to group 1 of the basic radicals. They both, the group reagent is dilute HCl. They both forms the precipitates, white precipitates. But because we are using the hot HCl, PbCl2 precipitate will get dissolved in the hot HCl, right? So the one which has precipitate in hot HCl, that is AgCl. The AgCl precipitate doesn't get dissolved in hot dilute HCl, whereas the PbCl2, when you use hot HCl, they get dissolved. So by that you can differentiate. Now aluminium and ferric ion, again they are kept in the same third group, and the group reagent that we use is ammonium hydroxide, ammonium chloride. So ferric hydroxide and aluminium hydroxide precipitates are being formed, right? Now on adding NaOH, the color of both the precipitate, aluminium hydroxide is white precipitate, ferric hydroxide is reddish brown precipitate. By looking at the color of the precipitates, you can get to know. But if you add excess of NaOH, your aluminium hydroxide will get dissolved, forming a complex. But the ferric hydroxide precipitate doesn't get dissolved in excess of NaOH. So by using dilute NaOH in excess, you can differentiate between the two ions. Now copper and nickel ion, so they both form sulfide. They can be identified in our wet analysis by sulfide formation. Copper ion is kept in group 2, which needs lower sulfide concentration for precipitation, whereas the nickel ion is kept in group 4, which needs higher sulfide ion concentration, right? So if I use H2S under acidic condition, the sulfide ion concentration is less because of the common ion effect. That will just enough to precipitate your copper ion, which needs less sulfide because its KSP is low as compared to nickel, right? So with this, the group 2 ion, that is copper, will get precipitated as sulfide, not the nickel. Okay, the barium sulfate, you know, the white precipitate. So by this you can differentiate, right? BaSO4, the white precipitates are being formed, so you can differentiate. So I hope you get your answer, guys, here. It was also there in the previous test. So the answer will be C. Okay, the next question, guys. Okay, question number 15th. You have A, which with alcoholic KH followed by heating forms this compound. I am pretty sure you'll quickly get it, aldol condensation happening. So what is A? This is the aldol product. So what is A, guys? Okay, by looking at the product, we can easily comprehend this is A. 2 molecules of this acetone, they just combine to form this, followed by heating, of course, because water is being removed. So this is our A, acetone. B is, you can see alcohol and acid, Canizaro. So the B has to be this, right? This is B, benzene with this. The benzene is not looking good now. Right? This is my B. Now when A reacts with B in the presence of KOH followed by heat, what is the product C? So this is your A, which has acidic hydrogen, can form carbon ion. This is your B, which doesn't have any alpha hydrogen, so it cannot form carbon ion. So the reaction, the cross like aldol condensation between the two A and B, this will form carbon ion, which will attack on the carbonyl carbon of this, and they'll form a product after eliminating water at the final step. So I'm pretty sure that you get your answer, guys. This is the answer. A and B, again the aldol condensation. So I'm sure you must have seen aldol kinase, or they are being frequently asked in the JMTs, and also they're very important because they have been asked in JEE exam a lot, right? So you should definitely know the mechanism and how you can make the products in lesser time, right? So the answer indeed is C. A and B, finally the aldol product. Now the next question, 0.3 molar solution of each of acid HA and HCl neutralized separately with 0.3 molar NaOH to the extent of 50%. Okay, 50% neutralization happens. The resulting solution are subsequently diluted 10 times, right? And the resulting solution are subsequently diluted 10 times to the current volumes. So you are supposed to tell the final pH of the solution after dilution, of course. So let's do it one by one. So my weak acid is there and I'm reacting it with NaOH, but half of the neutralization happens. So the extent of neutralization is 50%, right? I have 0.3 molar of this. I have 0.3 molar after neutralization, because the entire HA is not being neutralized. So after neutralization, half of the HA is neutralized. That means we are left with 0.15 molar of this, right? And we got 0.15 molar of this salt, because half of the HA, which is a weak acid, is neutralized by NaOH, right? So I have a weak base. This is also a weak acid, and the salt of weak acid with the strong base, right? The conjugate base also you can say. So they makes a buffer. Yes, they makes a buffer solution. Got it, guys? Yes. So we'll use pH is equal to Henderson-Hasselbalch equation pKa plus log of salt by acid concentration. Salt and acid concentration is same. So pH is equal to pKa. So pH is equal to pKa, and Ka value is given to us 10 to the power -5. That means pKa is 5. That means pH is 5. So we have acidic buffer with pH 5. So because it is a buffer solution, on dilution, the pH almost remains same, that is the 5. So the first case, the pH, in case of weak acid, the pH will come out to be 5. Got it, guys? Now let's do for second. That is HCl, right? Okay, now I have the second case, HCl. HCl is a strong acid which will be neutralized by base to form NaCl and water. Right? So molarity is 0.3, volume, say V is a volume, right? So these are the moles of HCl that is being neutralized by, because it is 50% the same molarity, but half of the volume is used because half of the acid we are supposed to neutralize. So the moles of NaOH is this. Got it? Yes. Now the pH, half of the moles of HCl are remaining, right, after neutralization, because these are the initial moles, these are the initial the moles consumed NaOH. Now how many moles of HCl are left after 50%? After 50% dissociation, how many moles of HCl are left, guys? Yes, moles of HCl left, of course. These are the initial moles, half neutralization. So after neutralization, how many moles are left in the solution? 0.15, half V moles are left, right? Yes, these moles of HCl are left. Now the molarity of HCl solution, because it is moles left divided by total volume. Total volume is V here, V by 2 here. So that is 3V by 2, right? Yes, 3V by 2. That is the total volume that is there. V volume of HCl is neutralized by V by 2 volume of a base. Yes, that is 1.5 So 0.15 V upon 1.5 V. This is the molarity. So the molarity of HCl, as HCl is a strong acid, right? So the molarity of HCl in the final solution after 50% neutralization will come out to be 0.1. And this is the concentration of H positive ion, right? Same 0.1. Now you diluted it 10 times, right? So further dilution, 10 times you dilute it. So of course the molarity becomes 1 by 10 because it is diluted, the final the solution becomes 10 times. So after dilution, this is before dilution, 0.1, right? The pH is 1. If I have to calculate the pH before dilution, the HCl solution will be 1. But after diluting it 10 times, the volume become 10 times, right? Yes. So the molarity becomes 0.01. That means the pH will be 2, right? After dilution, of course. So guys, 5 is the pH and 2 is the pH after dilution. So we'll mark our answer as B. So be careful. It has two steps, one with the weak acid, another with the strong acid. I'll say good, interesting question from ionic equilibrium. So the answer is B. Next question. The decomposition of a gaseous substance A, the next question, question number 17, guys. The decomposition of a gaseous substance A to yield gaseous product B and C follows first order kinetics. If the initial A is present and at 10 minutes after the start of reaction, pressure of A is 200 and Hg, okay, and that overall mixture is 300 mm of Hg after 10 minutes, then the rate constant, okay, you are supposed to calculate the rate constant using the equations for first order kinetics, right? This gaseous reaction, suppose the initial is P naught. After 10 minutes, reaction started, and after 10 minutes, P naught minus 2P, and it becomes P, this is 3, and it becomes P, and this becomes 3P, right? Got it? Yes. So we are given P naught minus 2P is equal to, after 10 minutes, the pressure of A is 200, and also we are given the total pressure P naught minus 2P plus P, that is P plus 2P, the total pressure, the sum of 3, right? That is equal to 300. So we get two equations. We can solve for capital P and P, small p and P naught. Two equations, two variable. We can easily solve what is the value of P and what is the value of P naught. Now, KT is equal to 2.303 log of P naught, initial pressure by P, right? So the first order kinetics equation we are going to put, nothing else, very, very, very simple, right? You calculate P and P naught using the two equations, and I'm sure putting the values, you can get your answer very easily without any doubt. T is the 10 minutes, you get P naught and P total, that is P naught plus 2P after 10 minutes, right? After 10 minutes, what is the total pressure of A? Sorry, of A here, you are supposed to put the pressure of A, that is P naught minus 2P, right? The pressure of A initially, that is P naught. So, and after, 10 minutes, it is already given. What is the pressure after 10 minutes? That is 200, no? After 10 minutes, it is given. So, this you already know. P naught you can calculate using these two equations, and after solving, you can get the K value. Very simple question, nothing difficult. Very, I will say, the straightforward question using the equations of first order kinetics, right guys? Okay guys, so this is what it is. So the answer that you will get is A here. So you can see your P naught comes out to be 250, PT is already 200, so you can solve. Question number 18. Consider the following transformations of the compound. Let's check. There is a compound P, on adding a reagent you get and followed by KMnO4, you get an optically active acid. The same compound P with NaNH2 and this carbonyl compound addition, you will get this, and platinum hydrogen, you will get this. So you are supposed to check, because the options you can see A and C, the P is given in both the options. You have to be smart guys, right? Because you are supposed to identify the P first, then only you can identify. So just start with A option, taking P as this, and then if you don't get your answer, then start taking P as this compound. Let's see if you can get the answer, correct answer or not. So let's do, right? So this is my P. Of course, on hydrogenation, all the double triple bonds get converted into single bond. This is fine. Yes. So this is fine. And in fact, I'll get the same with this also. Right? Now, let's see further. Okay, there is some reagent that is being added. H2 palladium. Right? Right? So that will convert your alkyne to alkene. Right? Now KMnO4 oxidation will happen. You will get a carboxylic acid here, there's this CO2 here, carboxylic acid here, carboxylic acid here, right? Because by using KMnO4, let me show you guys, by using KMnO4, which is a strong oxidizing agent, your double bond, they just break, they get oxidized to form carboxylic acid, right? The double bond breaks to give you oxygen, and the hydrogen present on those carbon, they will get converted to COH, right? So you get, so after suppose how many carbons are there? 1, 2 and 3. 1, 2 and 3. So this is the double bond. Just break the double bond. What you'll get? Carboxylic acid here. Carboxylic acid here. And also this carboxylic acid here. Right? So now this is your chiral carbon. That means it is optically active. So yes, similarly you can check by this. What NaNH2 will do? The triple bond will get, so you have CNA positive, it's negative with NaNH2, right? Followed by a nucleophilic addition on this, and the compound R also you'll get optically active, right? So with C you will get the desired products, the optically active acid, the optically active R, right? Yes. So how you are going to go ahead with the question, just check, make the products by taking P as given in option A. If you don't get the answer, because just if you do the product this way, you'll not get any optically active carboxylic acid, right? Then start by taking P as C, because there is a 2 option in which P is given, and you'll get, if the condition satisfy, then of course your answer is the P is C, right guys? Yes. And rest you can check whether it is matching with X and all. Got it? Done? So you can check in the solution also, and of course see the reaction. So this is P with PDC and quinolone. Your triple bond gets converted to double bond. On oxidation with KMnO4 you'll get optically active, and same with platinum, all the double triple bond will get converted to single bond. Hydrogenation happened, and on adding NaNH2 this will happen, and then the nucleophilic addition will take place, and final this product, which is again an optically active compound. So the C, this was the C, that is satisfying the entire scheme. So that is the answer. You can mark your answer whatever it is given. You have to check the correct or incorrect. Got it guys? So what was the answer? Of course C. Solution seems a bit lengthy, but don't be afraid, because they are not that lengthy actually. Just see this last scheme, you will get the answer. Okay. Which of the following is incorrect statement? Okay, let's check. Formation of missile takes place only below a particular temperature called Kraft temperature. So missile formation takes place above Kraft temperature. The very first statement is wrong. So the missile formation takes place above or equal to CMC, right? It happens, and the temperature should be above Kraft's temperature. Should not be below this, right? It should be above Kraft temperature. Clear? Yes. Okay, so this is a wrong statement. First, so CMC is this. Yes, there is a critical missile concentration above which the missile formation takes place, and that is the correct value for this. Is indeed a wrong, this is correct. Okay, arsenic sol. This is the way how we form the arsenic sol, right? Arsenic oxide with H2S. This is also correct reaction. For Tyndall effect, the scattering of light by your, colloids of suspension. That is the Tyndall effect that you must have done in your class 10th also. For Tyndall effect, the refractive indices of dispersed phase and dispersed medium different greatly in magnitude. Yes, this is one of the condition, right? That for Tyndall effect, the refractive indices of both dispersed phase and dispersion medium, there has to be a good difference between the two, and also the incident wavelength, right? The wavelength that you are using to show the Tyndall effect, that is also very important, right? So guys, so the wavelength that you are using, that should have the similar magnitude of as the diameter of dispersed phase. So these are the two conditions which are supposed to be satisfied when you have to see the Tyndall effect. One is the refractive index condition, another is the incident wavelength that you are using, that has to be comparable to the magnitude of the diameter of dispersed phase. So all are true. So we are supposed to figure out the incorrect, that is A indeed. Let's move on to the last SCQ. Okay. Consider the following statement and arrange in the order of true and false. Ammonium chloride on heating with aqueous solution of K2Cr2O7 concentrated H2SO4 produce deep red vapors. Ammonium chloride. Chlorides are there, so chromyl chloride test. So if chlorides are there, you add K2Cr2O7 along with H2SO4. So CrO2Cl2, very famous chromyl chloride, red color vapors that detect the presence of chloride ions, they will form. But the twist is we are using the aqueous solution. So your chromyl chloride vapor, they will combine with this H2 to form chromic acid. H2CrO4 is formed, so no vapor formation, because the chromyl chloride, it will get combined with H2O to form the acid. So of course no, that is the false statement. So let me write it as a false statement. Now the deep red solution of ferric acetate on boiling with water turns to brownish red solution. No, it will form precipitate. So this is also false. They will form the precipitate, not the solution. It will not get dissolved. They just settle down. So sodium nitrate solution acidified with acetic acid produces deep blue with the starch paste contaminated with iodide ion. Of course, guys, starch paste, when it comes in contact of iodine, it turns blue. This is true statement, right? Yes, so starch, white paste, when comes in contact with iodine, it turns blue. So of course, false, false, true. What option will go ahead with? That is B. False, false, true. Okay, guys. Okay, you can see here, guys. So chromyl chloride, CrO2Cl2 on reaction with water form this. Okay, now the numeric value equation. In how many of the reaction benzene is the major product? Okay, I'm sure the reactions I can see, they are not very tough reactions, they are pretty easy, and I'm sure you must have written in all these reactions in your notes and you must have done it, right? So let's see which will form benzene as the major product. Acetylene, ferric, red hot tube, trimerization, it will give benzene ring, written in NCERT reaction, very important. It's already there in the previous JMMTs. Okay, no, it will form CHOH, no. It will not give benzene, the reduction can happen. Diazonium salt, of course, with H3PO2 form benzene. Yes, from phenol, benzene can be formed by using zinc powder, reduction by zinc powder. Of course, this can give you benzene. Okay, so you can see OH, OH, and you have CH3COCl. Of course, elimination will happen and you'll get the 3 double bonds alternate. So this will also, by clearly looking at the molecule, no, you can make out it will give you benzene on elimination because heat is there, right? So dehydration can happen. Okay. Next is benzene sulfonic acid. You know sulfonation is a reversible process. You can do desulfonation. You can remove sulfonic acid group from benzene by using dilute acid, of course. So 1, 2, 3, 4, 5. So the answer is 5. In 5 options, you will get benzene as the major product, right? So that is the answer. It was easy. I will say it should not take much of your time, guys, cracking this question, right? Next, an unsaturated compound C4H8 reacts with, okay, peroxy acid is there, peroxybenzoic acid. How many products are formed? Okay, so we have unsaturated compound. The formula is C4H8, that is CnH2, and that is an alkene. So what possible alkenes we can have? 1, 2, and 3. They all have the same formula, C4H8. When you use peroxy acid, so epoxidation happens, right? So you get the epoxide being formed. Epoxide in all of these cases. Epoxide, the syn addition, epoxidation. Epoxides are being formed when alkene react with peroxy acid, right? Here we are using peroxybenzoic acid. So in all the cases, the syn addition, so the peroxy acid is being formed. So here we have syn addition. This can be cis and trans, right? So both will give the different products. Cis will give you the one product and the trans will give you the two products on epoxidation, and of course this. So you are supposed to count the total number of products being formed here. So I can see there is this chiral carbon here also. So two products here. Cis will give one, this will give two, and here also we'll get one product. So one. So let me count it. Two because it is D and L form. Chiral carbon is there. 1, 2, 3, 4, 5, and 6. 6 is the product. Epoxidation. This is epoxidation. The question based on epoxidation, the addition, syn addition on double bond by peroxy acid. So guys, you can have a look also. The answer is 6. Please see. So with cis you get a meso compound, and with trans you get two isomers, right? You can see. Okay guys, let's move ahead. How many of the following reactions result in the formation of colored precipitates? Time consuming. For this you are supposed to be very good in qualitative analysis or in organic chemistry. So many reactions are given. I will say this is a time consuming, and also check your knowledge for qualitative analysis. So HgCl2, HnCl4. HnCl4, the black precipitates are being formed because we are using HnCl2 in excess. So yes, precipitates are being formed. HgCl2Ki, Nessler reagent will be formed. No, displacement reaction happen, no colored precipitate is formed. NH4Cl with cobalt. Yes guys, nitrate ion with cobalt, that will forms a complex, yellow colored complex. So this will also form a complex. Diazonium, nickel DMG, red color complex will be formed. This also forms a complex. This also forms a complex. No Cu. CuI2 is formed, which is not colored. Cadmium cyanide is formed, which is not colored, right? So this potassium dichromate with H2SO4, this chromyl chloride is formed, right? Then sodium chromate and then lead chromate. Lead chromate precipitates are yellow in color, so this will also be formed. So let's check how many reactions will form colored precipitates. 1, 2, 3, 4, 5, 6, 7. So 7 reactions will have colored precipitate formation, guys. So to do this question, you are supposed to be very much thorough with your qualitative analysis or in organic chemistry. So those who were able to crack it and give the answer as 7, well done guys, keep it up. You are rocking in organic chemistry, right? So let's see. Yes, the answer is this. You can check the product forms also, different product, right? So you can check the 7. Okay. Now the next question. How many primary amines are formed when the following 3 amides are react and mixed with bromine KH? So Hoffman bromamide reaction, degradation reaction they are talking about. We have different amides, and how many amines we will get after mixing the 3 in Hoffman bromamide reaction. So in Hoffman bromamide reaction, no crossover products are formed, right? So each will give the corresponding amine. No cross products are being formed. So very simple. The answer is 3. We have 3 amides. We'll get 3 amines corresponding to each. Yes. So no cross products. So we'll get answer as 3 only. Got it, guys? No crossover products are found. Next, which of the following statements are correct? Let's check. BeO is amphoteric. Of course, aluminium, zinc, beryllium oxide, tin lead oxide are amphoteric in nature. Lithium bicarbonate is not found in solid state. Of course, because it has lithium ion, it has a lot of hydration energy because of small size, right? More charge density. So it doesn't exist in solid state. K2O2 is diamagnetic. KO2 has O2 negative ion. That is superoxide ion. Superoxide ion is paramagnetic and it has peroxide ion. Of course, this is also correct. Hydrated magnesium chloride on heating in dry air gives anhydrous MgCl2. No, it will give magnesium oxide. Aluminium chloride is soluble in excess of NaOH. Yes, of course. We just did it when we do that qualitative analysis question, aluminium and ferric. Anhydrous potassium nitrate on heating with potassium metal. Okay, KNO2 plus K gives K. Okay, K2 and nitrogen gas. This is also correct. This is the correct reaction. K2O and nitrogen gas you'll get. Lithium chloride is highly soluble in water. Of course, not lithium chloride. Lithium compounds are covalent in nature, right? So that because of the small size, high ionization energy, lithium beryllium compounds are covalent in nature, and like dissolve like, so it will not be very much soluble in water, which is a polar solvent. So what we are supposed to count? The correct statement. So 1, 2, 3, 4, 5. 5 is the answer. The 5 statements are correct here, guys. You can check. So the answer indeed will go ahead as 5, right? So 5 is the answer. So with this, we are done with this test also. I hope you did well. And what is the highlight of this test? Let me tell you. One, that there are like 2 questions in chemistry, 2-3 questions in chemistry, which are exactly from the previous JMMTs that you gave. So it is a time to introspect that whether you are able to do those questions correctly if you didn't do those questions correctly in the previous JMMT. So this is the biggest takeaway, I will say, after this test, that you are giving regular mock test, and whether you are learning or taking a note of the question that you are doing wrongly, right, or you are leaving the question in the test. So if the same question that you did wrongly in the previous JMT and still they are wrong in this, it is very disappointing. You are supposed to work on that, guys. That is the beauty or essence of giving the mock test, right? All the best, everyone. See you in another session.
Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. Today I am discussing Eklavya JEE Test-3, which was conducted recently. This is question number 1, in which we are given mod z minus 1 is equal to 3 as one locus, w minus iota is equal to 4 as another locus. They both are representing 2 circles. One is having center at 1, 0. One is having center at 1, 0, and other one is having center at 0, 1. The distance between the 2 circles, distance between the 2 centers is actually root 2. Okay, whereas the radius of both of them are 3 and 4 respectively. Now, if distance between centers is root 2 and radius are 3 and 4, so you can see that C1, C2 distance between the center is actually greater than R2 minus R4. R2 minus R1 actually. R2 minus R1, which means these circles will be intersecting each other, and also it will be such that they not only intersect but they contains each other's centers. Why it is so? Let me tell you. Suppose this is one circle and this is another circle. Okay, now my claim is, suppose this is the center of first circle, that is C1, and that is the center of circle C2. Okay, now distance between these two is just root 2, whereas the radius of the smaller circle is 3. So this is only possible if your center C1 and C2 are containing inside of each other. Okay, now what is the question next? They're asking the maximum value of mod z minus w. To get the maximum value, because this is the locus of z and this is the locus of w. The C1 is 1, 0, C2 is 0, 1. So maximum value will be when we choose z to be here and w to be here, so that they lies on the line joining their centers, and they are far apart, you can say. So in this case, you can see this is C2, so distance from here to here will be 4, and this is C1, so distance from C1 to this z will be 3, and in between it is root 2. So the maximum value of this mod will be 3 plus root 2 plus 4, that is 7 plus root 2, 7 plus root 2. So the value of A will become equal to 7. That is D answer. Okay, moving to the next question, question number 2. That's a question of limit, where I think LH rule is to be used. Also, Newton-Raphson formula is to be used. We are given limit t approaches to 0 plus and integral t square to t cube sine root x dx upon e power t minus 1 ln 1 plus t square. Now please see, for this limit, the things that are given in the denominator, we can use standard limits. This is e power t minus 1 upon t, then it will become equal to 1. Similarly, ln 1 plus t square upon t square will also become equal to 1 as t approaches to 0. But for that, I need to multiply here by t cube, so that this division by t and t square is nullified. Whereas in this step, I am not doing anything. I am just writing the same thing that is given in the question, sine of root x dx. Now, if you put these limits, this will be 1, this will be also 1. So we are left only with the t square here in the numerator. Now I will apply LH rule, L'Hopital rule. Limit t approaches to 0 plus, in denominator, as I said, this is 1, this is 1. So I will not differentiate these things. I'll differentiate just 3. This is t cube, which is 3t square. Whereas the differentiation of this numerator would be, for upper limit, it is 3t square into sine of under root of t cube. That is sine of t power 3 by 2 minus 2t into sine of t. Okay, so this will be the new function, you can say, for which we have to find the limit. Now I think it is very easy to see that for first thing, this 3t square is cancelling, so we are left with only sine t power 3 by 2. So this thing will become actually to 0, because after this cancelling, sine t power 3 by 2 will be 0. Whereas here, okay, for this part, I think we can write it like, yeah, we can write it like, first limit t approaches to 0 plus, and this first part is 0 as I told you, minus 2 upon 3 into sine t upon t. That's a standard limit. So I think this answer would become equal to minus 2 upon 3 for this question. I think option here is D. Okay, moving to the next question. Yeah, we are given z r to z, where r is set of real number, that is set of integers. Fx is equal to, this is gif of x plus 2 plus gif of x square minus 8. Okay, please see, I can write this function as gif of x square, and this can be broken down into two parts. One is gif of x plus 2, because 2 is integer, and this 2 can be added to minus 8, so we will be having minus 6 here. Now please see, we have to check whether this function is 1 1 many 1. So first thing is very obvious that it is not 1 1. Why? Because if you put x between any two integers, maybe 0 to 1 if you put, okay, then gif takes just one value, that is 0. So the function will be taking just one value for all x that are lying between 0 to 1. So it has to be many 1. Okay, now coming to onto or into, to get whether it is onto or not, I think we need to check what is its range. Codomain here is integer, all set of all integers. So here you check, if gif of x is 0, then the value it will become equal to, the value of this function will become equal to minus 6. If gif of x is 0. Now if gif of x is 1, sorry, is 1, then the value will become equal to minus 4. If gif of x is equal to 1. Now please see, if I keep inputting the values of x, my values of gif x will be either 0, then 1, then 2, and so on. You cannot have value in between 0 to 1, but you can see we are jumping the values here. We are jumping the values here. If I'm putting gif of x equal to 0, or then if I am putting it as 1. So minus 5 I am not able to get, and I think this value can never be obtained, and hence this function cannot have z to be the range. Its range will be proper subset of z. So this function is many 1 and into. So answer is D for this question. Now coming to question number 4. Sine inverse x plus sine inverse y plus cos inverse z is equal to minus pi. So please see, whenever such questions are given, they are based on the range of these functions. You know, sine inverse x, the minimum value can be minus pi by 2. Here also the minimum value is minus pi by 2. Here the minimum value is 0. So if you add these three minimum values, then only you can get sum to be equal to minus pi. If you choose any value that is higher than minus pi by 2 for this sine inverse x, or for this sine inverse y, or greater than 0 for this cos inverse z, you cannot obtain the sum equal to minus pi. So for this equation to have some solution, we need to have sine inverse x to be equal to minus pi by 2, which means x will be equal to minus 1. Similarly, y will be equal to minus 1 and z will be equal to 1. Now we have to put these values here. So x into y will be 1, y into z will be minus 1, x z will be minus 1. So answer will be minus 1, that is given in option number A. So answer is A for this question. Now coming to question number 5. Consider complex number z satisfying satisfying this relation, and mod z is equal to 3, then we have to find z will move on a straight line or on a straight line parallel to imaginary y-axis, here real axis. Okay, imaginary axis, not y, imaginary axis, then sent on a circle or on a pair of straight line passing through origin. Now in this case, we will first solve for z. We will take z on one side. So I'll be having that is w bar minus 2 iota. If I take this 2 iota z term on the right hand side, and that is equal to 3 w bar. Okay, now if I take mod both sides, like this, we can use the property that it is mod z into mod of w bar minus 2 iota is equal to 3 into mod of w bar. Mod of z is 3, so this will cancel this 3, so we are left with mod of w bar minus 2 iota is equal to mod of w bar. Now mod of any complex number is same as its conjugate, so if I take conjugate inside for this mod, it will become w minus, actually plus, because conjugate of iota is minus iota, and that will be equal to w only. Now you can see it's a very standard locus. This w is at equal distance from 2 points. One is 0, 0 here, and here it is minus 2 iota. That means 0, minus 2. So this w will be actually lying on perpendicular bisector of line joining these 2 points, 0, 0 and 0, minus 2. So that will be lying on this kind of line, which is actually parallel to real axis. So answer for this question will be A. Yeah. Now moving to the next question. Here we are given that this is ellipse, then we have to find the minimum value of x square plus y square. Now this ellipse is having center at 1, 0, and the value of A is 4, that is semi-major axis. If this point is 1, 0, so for distance before it, this point or this end of major axis will be at minus 3, 0. Now please see, what is x square plus y square? We can consider x square plus y square as distance of a point from origin square of distance of any point from the origin, and origin will be somewhere here, 0, 0. And this xy pair would be a point lying on the locus given here. That means it should be lying somewhere on the ellipse. Now to get this minimum, I think it will be point somewhere like this. Maybe x, y will be here, and that is the minimum distance. Then how to identify for which value of x it will be having minimum value? Now there can be two methods. One is that from 0, 0 you can easily see there are two normals, one meeting ellipse at minus 3, 0, and other normal meeting the ellipse at, I think it will be 5, 0. It will be 5, 0. Okay, and there will be two more normals. One will be maybe at this x, y, and one will be symmetrically to this thing. I think it will become x, minus y. Okay, now by knowing that a normal passing through 0, 0, at which points it is going to meet to the ellipse other than these 2 points, I think we can say these points will be at the nearest distance. Okay, so from there we can find the minimum value of x square plus y square. Again, one more thing, sometimes this kind of normal, when they meet to this kind of point, they may be at maximum distance, sometimes they can be at minimum distance. We can do the comparison. By that we will be able to answer whether it's a minimum or it's a maximum. Okay, that is one way. There is another way. Please see, the other way is that I can take x to be equal to 1 plus 4 cos theta and y to be equal to 3 sin theta. Okay, now we just have this x, y in terms of single parameter theta. Take x square plus y square using distance formula. That will be 0 minus x whole square, 1 plus 4 cos theta whole square plus 3 sin theta whole square. So it's a function in one variable theta. We can find the minimum of this thing. Okay, if I open it, it will be 1 plus 16 cos square plus 8 cos, and here it is 9 sin square, whom I will write 1 minus cos square. Now everything is written in terms of cos alone, and it's a quadratic. 16 minus 9, that is 7 cos square plus 8 cos, okay, plus 10. Okay, it's a quadratic in cos whose minimum value will appear, whose minimum value will be when cos is having value equal to minus 4 by 7. It is actually upward parabola. If we draw in terms of cos, the minimum value will appear at minus b upon 2a. So it is minus 4 upon 7. Okay, and the value minimum, and this minimum value will be equal to, if you put minus 4 by 7 there, so 7 into this thing, so it is 16 upon 7 minus 32 upon 7 plus 10. Okay, so this becomes 10 minus 16 upon 7. 70 minus 16 is, I think, 54 upon 7 will be the answer for this question. So answer is C for this question. Okay, you see, yeah. Moving to the next question, we are given a parabola. Y square is equal to 4a x minus b bisects the circumference of this circle. This is a standard circle whose center is at origin, radius is 4. Okay, and we are given a parabola. It is bisecting the circumference of the circle. Focus of the parabola coincides with the center of the circle. So focus will be here. Now please see, this is a parabola. Either it's a parabola either right opening or left opening depending upon the value of a. But in all scenarios, the focus has to be x minus b equal to a. Okay, this 4a is in place of latest rectum. X minus b is in place of y square is equal to 4ax. If you compare with this thing where the focus is always x is equal to a, there we find the focus. So here the focus will be at x minus b equal to a. So x will be equal to a plus b, and we are given focus lies on the center of the circle, that is 0 0. So this will be equal to 0. So a plus b has to be equal to 0. So from this also I think some of the options can be eliminated. These two options are not possible because a plus b equal to 0 means a equal to minus b. So division of these mod has to be 1. So C and D cannot be the answer. Now moving to the next thing. Now suppose I take a to be negative. If I take a to be negative, in that case the parabola would be, left opening like this, and its vertex will be at b comma 0. Okay, and in this case, because we are given this parabola bisect is circumference, so the point where it will be meeting the circle, they have to be diametrically opposite ends, and also the focus of the parabola is on the center of the circle. So this is actually diameter as well as it is the latest rectum of the parabola. Latest rectum, if you know that distance, the length above focus is 2a, or rather mod 2a, and the radius of circle is 4. So this 2a has to be equal to 4. Actually mod of 2a has to be equal to 4. So a will be equal to minus 2 because I have taken a to be negative. If a was positive, then this parabola would have been right opening. I'll talk about that later. So a is minus 2. So from that, if a is minus 2, b will be equal to 2. So from this mod a plus mod b becomes equal to 4. Okay, suppose I would have taken a to be positive. In that case, this parabola would have been just the mirror image of what we have just now about the y-axis. So that in this case, a will be positive. Yeah, here b will be negative. So this vertex of the parabola will be at b comma 0, and remaining calculation will be same. Okay, so answer for this question is B. Okay, moving to the next question, that is question number 8. That PQ divides join of A and B in the ratio 3:1. Okay, this question is based on the property, let me tell you, A, B. Okay, and P is the point that divides join of AB in the ratio 3:1. I can take this as 3K and this as K. I'm talking about the length, not the ratio. 3K is the length, ratio is 3:1, AP is 3K, PB is K. And similarly, Q divides the join of AB externally in the same ratio. Okay, so Q will be somewhere here. That means distance from distance of Q from A will be 3 times the distance of Q from B. Okay, now you can do the calculation. You can see if this distance has to be 3 times the distance from B, in terms of 3K itself, let me tell you, this entire distance has to be 6K and this has to be equal to 2K. You can check. Okay, then the ratio of distances of Q from A to B is 3:1, and you can see the summation also, 3K plus K plus 2K is 6K. Okay, so if ratios are like this, 3:1 and 3:1, the distances would be like this. Okay, now one more thing they have given, R is the midpoint of AB. Midpoint of AB means it should be at 2K distance from A. It should be at 2K distance from B. Okay, now let me tell you the property. Whenever you have 2 points like P and Q dividing AB in the ratio, same ratio actually, internally as well as externally, then the distance is AP, AB, AQ, which they are asking in option number C and D. They are always in HP. You can check it here also. Distance of AP is 3K. Distance of AB is 4K. Distance of AQ is 6K. Now you can check, this is not AP. If you divide the entire thing by 12K actually also, so it will be 1/4 1 upon 3 and 1 upon 2. What I have done, I have divided the entire thing by 12. So 1 upon 4, 1 upon 3, 1 upon 2. Now you can see in the denominator 4, 3, 2 is a decreasing AP, which means it is HP. So these two options are wrong. Now there is one more property, that if R is the midpoint, then this RP, and RQ, they are in GP. This can be checked here also. Like RP, if you find, RP would be just K. RP would be just K, because A to P it was 3K, A to R is 2K, so that will be equal to K. And then RB, if you check, it is equal to 2K. RB, it is 2K, and then RQ, if you check, RQ, so 2K plus 2K is 4K. So it can be clearly seen that it is forming a GP. Okay, that's a property, and that can be done with the help of some properties of circles also, but I will not talk about it here. For this kind of ratios, I think we have proved it that it is the GP. So answer is B. Now coming to question number 9. Here we are given a sum of infinite series in tan inverse up to infinite. Here the general term is tan inverse 2 raised to the power R upon 2 plus 2 raised to the power 2R. If you take 2 common from the denominator and you take 2 common from the numerator also, they will get cancelled. So it will be 1 plus 2 power 2R minus 1, which I am writing it as 2 power R into 2 power R minus 1. In the numerator, it will be 2 power R minus 1, which I can write it as 2 power R minus 2 power R minus 1. Okay, hence this becomes equal to tan inverse 2 raised to the power R minus tan inverse 2 raised to the power R minus 1. Okay, now we will keep putting values of R is equal to 1, then 2, then 3, and so on up to infinity. And you can see the summation. For R is equal to 1, my first term would be tan inverse 2 minus tan inverse 1. The next would be tan inverse 2 power 2 minus tan inverse 2. If you put R is equal to 3, it will be tan inverse 2 power 3 minus tan inverse 2 power 2, and so on up to infinity. So here you can check this tan inverse 2 is getting cancelled with this. Tan inverse 2 power 2 is getting cancelled with this, and likewise all terms will get cancelled. We will be left with just one term here, okay, and the one last term here in this bracket. Okay, as we keep increasing the value of R, the term here will be actually this 2 power n, and n tending to infinity, that term will become infinity as you keep increasing the value of R. So tan inverse, this thing will become pi by 2. Tan inverse, this thing will become pi by 2, and the first term here is tan inverse 1, that is pi by 4. So difference here is pi by 4. So answer for this question should be pi by 4, and it is given in the option number A. Answer is A for this question. Yeah. Coming to question number 10, here we are given area bounded by S is equal to x comma y such that this inequation comma x comma y belongs to R and y less than 0 is equal to where R is set of real number. So here we have to solve few things. Number one, the expression inside the under root should be positive, which is x plus y plus 3 equal to 0. So please see, x plus y plus 3 is actually representing a straight line if we equate this to equal to 0. If x plus y plus 3 is equal to 0, it will be a straight line whose x-intercept and y-intercept both will be minus 3, minus 3. This will be 0, comma minus 3, and this will be minus 3, comma 0. And this line is x plus y plus 3 equal to 0. But we want x plus y plus 3 greater than 0, because inside under root only positive or 0 quantities can be defined. So for this, I think the region about this line where origin is lying, you can check, because if I put origin in this expression, we are getting 3, that is positive. So this is the region where this expression would be positive. That is one thing. Now second expression, y minus x plus 2 equal to 0, if I draw, x-intercept would be 2 and y-intercept will be minus 2. So something like this. X-intercept would be 2 and y-intercept here would be minus 2. So 0, comma minus 2 will be this point. And here again, if you put 0 to this expression, we get 2. So once again, towards the origin will be the region where this is defined. Okay, so above this straight line and again above this straight line also. So this kind of quadrant or whatever you say is the region where these two things will be defined. and also we are given y negative. Y negative means it will be below this, this will be below the x-axis. So this is the region that is defined for y less than 0, where x plus y plus 3 is positive, y minus x plus 2 is also positive. But one more thing we are given, suppose these two are positive, then we can do the squaring and we will be getting x plus y plus 3 less than or equal to y minus x plus 2. Here y will get cancelled, so x will be less than or equal to minus half. So for x to be less than or equal to minus half, if I draw it here, I think it is a line here. In fact, this point of intersection is minus half only, where these two expression will become equal to 0. And if you put x is equal to minus half, your y coordinate will be minus 5/2. Okay, so one more thing is there, that is x less than or equal to minus half. So this is the region which we are looking for the area, which is just a triangle, rather right angle triangle. And here you can check, this is actually minus half, x coordinate minus half. So that base is 5/2. And here this height is also 5/2. This is also 5/2. So the area will become equal to 1/2 into 5/2 into 5/2. That is 25/8. That is the area of this question. Okay. So C should be the answer of this question. Yeah. Moving to the next question, that is question number 11. We are asked the range of the function. Okay. So in this question, fx is equal to under root of 1 plus x square upon 1 plus mod x. We have to find the range of this thing. Now in such question, we can do some substitution, rather trigonometric substitution, to make them simpler. Here what I'm thinking of, that we take x is equal to, or rather mod x is equal to tan theta. See, this fx here is actually equal to under root of 1 plus mod x square, and here 1 plus mod x. So if I take mod x as t, okay, now x can take any values, but mod x will take values from 0 to infinity. It will take from values from 0 to infinity, and for that the theta will take value from 0 to pi/2. Okay, now if I do this substitution, this function in theta now will be equal to secant theta in the numerator. 1 plus tan square theta is secant square theta. Under root will give you secant only. Theta is in first quadrant, so there is no need of any minus sign putting there. And 1 plus this is what, tan theta. Yeah, tan theta. Now if I multiply numerator and denominator both by cos theta, it will be 1 upon cos theta plus sin theta. Now please see, cos theta plus sin theta can be written as 1 upon root 2 sine of theta plus pi/4. Okay, now for this expression, I think that's a standard thing, but I'll explain you because my theta is only from 0 to pi/2. So if you put theta 0, this will be sine pi/4. If you keep putting values towards pi/4, this will take maximum value of sine as 1, and then after pi/4 to pi/2, again the values will decrease from 1 to 1 to the value will decrease from 1 to 1 upon root 2. Actually, the graph of this would be something like this. This is a graph of sine theta plus pi/4, where this is the point where theta will be pi/4. This is the point where theta is 0, and this is the point where theta is equal to pi/2. So you can see, as your theta changes from 0 to pi/4, the value of sine increases, and then again it is decreases. So the function in the denominator with root 2 sine will have range from, I think at 0 it will be 1 by root 2, and let me multiply by root 2 also here. So at 0 this value will be 1, and at pi/4 the value would be root 2. So the function in the denominator actually will be having range from 1 comma root 2, both side close bracket, because 0 is also included, pi/4 is also included, pi/2 is not included, but the value which we are getting at pi/2 is obtained at 0 also, then it's okay. Okay, now if you take the reciprocal, so the range would be, the final range would be reciprocal of these two things. So 1 upon root 2 comma 1, close bracket, close bracket. So answer of this question is B. Yeah. Moving to the next question. That is question number 12. Here we are given, let y equal to yx be a continuous function satisfying the differential equation dy plus xy into dx is equal to x dx. Satisfy y 0 is equal to 2, then we have to find the GIF of this 3y of under root ln 2. Let us see how we can do this question. I think these two terms are of dx. So I can write this as dy is equal to x dx common, and I think 1 minus y on the other side. 1 by y we can take towards this left side. 1 minus y is equal to x dx. That is what we are getting. I think it's variable separable, very simple question. And if you do the integration, it will be minus ln of mod 1 minus y is equal to x square by 2 plus c. At 0, the value of y is 2. Okay, so please listen carefully. To keep this function continuous, it will be better if I write this expression here as dy upon y minus 1, okay, is equal to x dx. Why I am saying so? Because if you are having 1 minus y in the denominator, then you tend to write like this. But if you are having like this, then your integration will be y minus 1 is equal to x square by 2 plus c. They both are same thing, because the mod of 1 minus y and mod of y minus 1, they both are same thing. But actually, when you put y is equal to 2, this will open with positive sign. Here you have to put one forced minus sign outside to make it positive. To avoid this, to avoid the confusion, I am taking this thing. You could have taken this also. If you take this at x is equal to 0, so we will be getting minus ln 1 is equal to 0 plus c. This gives c to be equal to 0. This gives us c to be equal to 0. Now another thing here, once we have found the value of c, okay, now what will be the function? If I take this thing, I think because the function is continuous, and this kind of function cannot be continuous if value of y comes to be 1 in between. So already we have got y value to be 2. So all values should be such that the values of y are greater than 2 only. So this mod thing I will open just like this only. So it will be ln of y minus 1 is equal to x square by 2. Okay, why I am writing like this? Because already we are given y is equal to 2 at x is equal to 0, and we are given function to be continuous. So if you change sometimes as y minus 1, sometimes 1 minus y, at y is equal to 1, in any case this function cannot be continuous. But we are given function to be continuous, so this is possible only if this expression is always such that y is greater than 1. So I have kept it like this. So here we get y minus 1 is equal to e power minus x square by 2. And now they are asking in the question the value of function. Let me use this slide. Yeah, under root ln 2. So I will put under root ln 2 here. So it will become e power minus, under root will remove by this square. So 1 by 2 ln 2. I think this becomes 1 upon root 2. Yeah, 1 upon root 2. So the value of y here would be equal to 1 plus 1 upon root 2. And they are asking the GIF of 3 times of this thing. So g 3 times y, GI of 3 times y will be equal to 3 plus 3 upon root 2. Okay. So it is almost 3 plus, I think root 2 is 1.4. So 2 point something, 2.08, maybe something like this. So the value has to be equal to 5. Is there any such option? Let us see. Yes, C should be the answer of this question. Yeah. Now coming to question number 13, it says fx is equal to maximum of mod x minus 1 comma x minus 2 up to mod x minus 5, and similarly gx as minimum of mod x minus 1 and so on up to x minus 5. Same things they are given, but in one it is maximum, in another it is minimum. We have to find the area of region bounded between y is equal to fx, gx, x is equal to 0 and x is equal to 5. Now first of all we have to understand what this fx function is. Now to understand that, please understand that mod of x minus r actually represent distance of x from r on real line. Now considering this thing in our mind, we will check that as my x ranges from 0 to 5, how maximum minimum values will change. Okay, this is x is equal to 5, this is x is equal to 0. Now please see, between this 1 here, let us say 2 here, 3 here, and 4 here, and 5 here. Okay, now for this fx to be maximum, if my value is at 0, I think the maximum value will be from 5 only. And not only at 0, but if you increase value of x from 0 to 1 and then 2, and I think up to 3, the maximum value will be from 5. At 3, distance of 3 from 1 and from 5, they are same. If we have to compare between these 5, the maximum value from 0 till 3, okay, I think it is coming from this mod only, and because x is less than 5, so it will be opened like 5 minus x. Okay, so up to 3 the value will be given by this function, and after 3 you can see the maximum distance will be now from 1. Okay, and it will be now x minus 1 because x is greater than 3, so mod x minus 1 will be written as x minus 1. These mods x minus 2, x minus 3, x minus 4, they will always give you intermediate values. They can never give you maximum values as compared to mod x minus 1 or mod x minus 5, so they are useless for us for this fx at least. Okay, so this will be the graph of this thing fx, and this point is where the value is coming out to be. At 3 it will be 2, at 0 it was 5, here it was 4, the point this was 4. Okay, so this is the graph of fx. Now coming to graph of gx, minimum of mod x minus 1 and so on. Now to have this minimum using this definition here, I think if I am at 0, the minimum value will be, the minimum value will be from 1. Minimum distance will be from 1 because 1, then 2, then 3, then 4, then 5. So any x that is between 0 to 1, the minimum distance will be from 1 only. That is given by mod x minus 1. Not only between 0 to 1, in fact after 1 also up to 3 by 2, the distance of points between 1 to 3 by 2, they are at minimum distance from 1, because between here the distance from 1 will be less, distance from 2 will be more. So I think still we are having minimum distance defined using this mod x minus 1 only. But after you cross 3 by 2, I think the point at minimum distance will be 2. So here it will be x minus 2, mod x minus 2. Here it was mod x minus 1. Here also it was mod x minus 1. Okay, that's a graph of mod. We know it, V shape. We can write then after opening mod also, but right now I'm writing just as mod x minus 1 from 0 to 1 and 1 to 3 by 2 also. After this 3 by 2, it will be 2, that is at the nearest distance from all such points. Likewise up to 2.5, that is 5 by 2, also the minimum distance will be from 2 only, and then minimum distance will be from 3, and then from again 3, then from 4 by 4 only, and then from 5. So you can see these will be the point of kind of maximas. 7 by 2, that is 9 by 2. So this is how the graph of gx will look like. Mod x minus 1 from 0 to 3 by 2, then 3 by 2 to 5 by 2, it is mod x minus 2, and likewise. Okay, so these are two graphs, and we have to find the area between these two things. I think there can be two ways, two things that we need to calculate. One is the area of this fx with x-axis, and then the area of this gx with x-axis, and we can subtract that. Okay, now to find this area by fx, I think it is just the 2 trapezium actually. Here it is 2, here it is height 5. So the area above A1, I am writing it as 1 by 2 into sum of parallel sides, that is 5, that is 2, so 5 plus 2, 7, into distance between them, that is I think 3 here, plus then this point to this point, that is 2, that is 4, 2 plus 4 is 6, and distance between these two is just 2 here. So answer would be I think 21 by 2, 21 by 2 plus 12 by 2. So I think it is 33 by 2. That is one thing. Now coming to A2, that is the area bounded by gx and the x-axis. Here it is 1, so this will be 1 by 2. Now for this kind of areas, please see, for each such triangle, the base is 1, but height here is just half. You can check this point is 3 by 2, comma half. And it is same whether you use mod x minus 1 or you use mod x minus 2. So height will be 1 by 2, base is 1. So for A2, the first triangle is having area equal to, 1 by 2. But after that we are having 1, 2, 3, 4 such triangles whose areas are 1 by 2 into 1 into 1 by 2. Base is 1, height is 1 by 2. So here it will be equal to 1 by 2 plus I think 1 only. Yeah, 1 only. So that is 3 by 2. 3 by 2. So that is the area of gx with x-axis, and that was the area of fx with x-axis. We have to take the difference of these two, then only we will be able to find the area bounded between these two things. This kind of area, sorry, not this. Yeah, this area we will be able to find. Okay, so answer should be 33 minus 3, that is 30 upon 2 is 15. So seems like answer should be C here. Let us see what answer they have given. Yeah, C is the answer. Now coming to question number 14. Here we are given 5 fair dice are thrown simultaneously if the probability that highest number obtained is 4. Okay, is this, then we have to find the value of A. Okay, we are having a dice which is having 6 dots on it, 1 2 3 4 5 6. Okay, now if I want my outcomes from first 4 numbers, 1 2 3 4, so on every dice I have 4 options, that from 1 2 3 4, second dice 1 2 3 4, third dice 1 2 3 4, fourth dice and fifth dice. So these will be total number of outcomes if my outcomes are from first 4 outcomes. But if you are doing this thing, there are chances that you never get 4 on any of the dice. Always you get, let's say 1 2 3 1 2 3 1 2 3, so you never get 4. So those cases are not acceptable to us, because they're asking probability that highest number obtained is 4. So what we need to do, we have to subtract from this those cases when all the outcomes on the dice are from first 3 numbers, 1 2 3. So in that case it will be 3 3 3 3 and 3 on all the 5 dices. If your outcomes are from first 3, so it will be 3 power 5, and this was when all outcomes were from first 4 outcomes. So we have subtracted precisely those outcomes which we do not want. So my probability will become 4 power 5 minus 3 power 5 and whole divided by 6 power 5, because if that sample space is to be considered, it has to be 6 into 6 5 times. So 4 power 5 is how much? I think 1024, and 3 power 5 is 243 upon 6 power 5 they're asking, and this is equal to 11A upon 6 power 5. So my A will be equal to difference of these two, 4 minus 3 is 1, and here it is 8, and 9 minus 2 is 7 upon 11. Divide by 11, it is 71. Yeah, there is one option B. So answer for this question is B. Yeah. Coming to the next question, here we are given fx equal to this thing, then f of GIF x, greatest integer function x, is not defined for. Okay, now please see, if this is a function which is not defined, this fx is not defined when this quadratic, which is x square minus 17x plus 16 is equal to 0. If you open it, I think we can do the, you can split the middle term as I think 11 into 6 here. So it is either 6 or 11. But if we are talking about function f of GIF x, then it will be not defined. Same thing, not defined if GIF of x is either equal to 6 or equal to 11. That means x can take value from 6 to 7 or 11 to 12. So answer for this question will be I think C. 6, 7 union 11, 12. Yeah, fine. So moving to the next question, question number 16. Yeah, this question we are given fx is equal to x plus 1, x square plus 1 for 2 different ranges, gx also in 2 different ranges, and hx is equal to x. And d upon dx of f of g of h of x at x is equal to 0 we have to find, and we are given whether it is equal to 1 or 2, does not exist, and what is the reason for if it does not exist. Okay, now if this kind of functions are given, I think direct differentiation should be avoided. We should go with first principle rule. Okay, that is differentiation by first principle, where we take the limit of differentiability like that. So at x is equal to 0, if we have to find the derivative, so first I will find RHD. RHD means it is limit h approaches to 0, and it will be f of g of h of 0 plus h minus f of g of h of 0. Here also that many brackets upon h. That's the first principle, nothing else I have done it here. Now please see, if h is 0 plus here, First of all, this thing is easy. H0 is equal to 0. At 0, G0 is 1. At 1, Fx is 2. So here it has to be equal to 2. Now coming to this thing, H of H will be H only, that is slightly positive. For slightly positive, again given by the same thing, so it will be e power H. E power H will be slightly greater than 1. So again by same thing here, so it will be e power H plus 1 minus 2 upon H. So that is what we will be getting for RHD. I think standard limit, it will be equal to 1. Now similar way we will be doing calculation for LHD. LHD, it will be limit H approaches to 0. Again I am putting plus here, but please see I will be putting f of G of H of minus H here, and minus f of G of H of 0, which will be again same as 2 upon minus H here. Okay, now H of minus H will be minus H, that is slightly negative. Slightly negative means it will be given by 1 plus ln of 1 plus x. So here it will be, let me take some more space. Okay, I'll do one thing. Yeah, now fine. So here for this part, limit H approaches to 0 plus, when Hx is giving you minus H, it will be negative. So we will be take this thing here. So it will be f of, for G I am putting 1 plus ln of 1 minus H minus 2 upon minus H. Now for f, please check, this ln of 1 minus H will be slightly negative. So this 1 plus ln 1 minus H will be slightly less than 1. So we will go with this function here. So here it will be limit H approaches to 0 positive. Okay, and we can write it as 1 plus ln of 1 minus H whole square plus 1 minus 2 upon minus H. Okay, now if we check that at 0, what will be this value? I think it will be 1 plus 1, 2. So it is 0 upon 0 form. Okay, so we can now calculate the limit. Yeah, I am having space. Yes. So what I will do, limit H approaches to 0 plus, that is a square minus b square form, where it is minus 1 here. So this minus this will be ln of 1 minus H, one bracket, and other bracket will be 2 plus ln of 1 minus H in the numerator and divided by minus H. Okay, and these two things are multiplied. These two things are multiplied here. The second bracket, which is 2 plus ln 1 minus H, is directly 2 if we put H as 0 plus, whereas the first thing, limit H approaches to 0 plus, that is ln 1 minus H upon minus H is 1 and into 2. So the limit is coming out to be 2 here, where we got that limit of RHD was 1. So it doesn't exist, but both LHD and RHD exist. So answer for this question should be C. In the D option they have given does not exist, as one of the LHD or RHD does not exist. So D is not correct. So C is correct for this question. Yeah, C is given. Now moving to the next question, number 17. Yeah, this is question number 17 here. Here we are given fx be a function satisfying this thing. F dash 0 is 2 and we have to find f of 2. Okay, to do such questions, because we are not given whether function is differentiable or not, we cannot do direct differentiation. In fact, we should avoid. So to do this thing, what we will do, we will find f dash x with the help of first principle only. Limit h approaches to 0. It will be f of x plus h minus f of x upon h. That's the universal definition of derivative. H approaches to 0. And here f of x plus h, I will use this definition. So it becomes e power x into f of h minus plus e power h into fx minus e raised to the power x plus h. Okay, and then fx, yeah, just fx upon h. Now we will simplify it. Limit h approaches to 0. E power x, if I take common from this and this term, we will be having f of x. Oh wait, I think I have put plus here. Yeah, minus e power h, and for the two remaining terms we can take fx common. It is e power h minus 1. I'll write these two brackets separately. H here and H here. This thing is, I think, standard limit, that is 1. And here again I will use some standard limit only, not LH, because I'm not sure of function being differentiable. So e power x outside, I will write f of x minus, one more thing before I write this step here, that if you put x equal to y equal to 0 here, you can check f of 0 is coming out to be equal to, I think, 1. Please check. Both zeros, so f0 here, that will be f0, and that will be 1. So f0 becomes equal to 1. Okay, so e power x into f of h minus f of 0, I'm writing, which is actually equal to 1, then plus 1 minus e power h, I'm writing, upon h. And this is actually 1, so we can write just fx here. Okay, in this case, these two limits, I think this is f dash 0 only by first principle, and this e power h minus 1 upon h, same standard limit. I think this will give us minus 1 here. So 2 minus 1 will be, so this will be equal to, let me write it here. So what we were finding as of now, f dash x. F dash x is equal to e power x, and please remember f dash 0 is 2 and this limit is minus 1, so 2 minus 1, 1, and plus fx. So this is what we have got as f dash x. Derivative of function is equal to e power x plus f dash fx. Now we need to solve it by differential equation to get my function. So how we can do it? Please see. I will take fx as y. So dy upon dx is equal to, or let me do one thing, let me bring this on the left hand side, minus y is equal to e power x. I have taken fx as y. I have taken this as y. So dy upon dx minus y is equal to e power x. It is linear differential equation whose integrating factor would be e power minus x, and solution would be y into e power minus x equal to e power minus x multiplied with this. So this is just 1 dx plus some constant, so x plus c. Okay, we are also given that f0 is 1. Actually, we found f0 to be equal to 1. So at x is equal to 0, y is equal to 1. So 1 here, 0 here. So the value of c will be equal to 1. C is equal to 1. I will write this thing now here. Okay, I will write it this thing here. So my y or fx is equal to c as 1. So it is e power x into 1 plus x. E power minus x will go that side, so e power x into 1 plus x. Now they are asking f of 2. So f of 2 will be equal to 3 into e square. So C is the answer. Okay, I think it was a bit lengthy question. Now moving to the next question, that is 18 actually. Here we are given that for the data 1, 2, 4, 5, a comma b, variance is minimum possible for any a comma b belongs to R. Then which of the following is false, they're asking. And they want variance to be minimum possible. So let me tell you one idea here that will work. That if first 4 data are such whose mean values for first 4 which are given to us is 1 plus 2 plus 4 plus 5. I think 3 plus 4, 7 plus 5, 12 upon 4. So that is equal to 3. Okay. Now, if you want variance to be minimum, which measure the dispersion, your both data should be that they are equal to 3. Both of them are equal to 3. Then only you can say that they are not adding to any variability of the data. So my A and B both have to be equal to 3 only to get minimum possible variance. So A equal to B is true, but we want false data. Minimum variance. Achha, now we have to find minimum variance also, but before that, I think A is equal to 3 is right, B is equal to 4 is false, so answer will be D, and minimum variance also we can check. Now I will tell you minimum variance and also another way to say why A and B both should be equal to 3, 3. Now to do this thing, what I will do, I'll use the property that variance doesn't change if you add or subtract the entire data by some fixed number. So here I will be subtracting the entire data by 3, which is the mean of first 4 data. So if you subtract by 3, my first data will be minus 2, then it will be minus 1, then it will be 1, and then it will be, I think, 2. And then it is A dash and B dash. Okay, here A dash is equal to A minus 3 and B dash is equal to B minus 3. Okay, B dash. Okay, so this data set and this data set will have same variance. Now to find the variance, we just need to do the squaring, sum of squares divided by number of data. So 4 plus 1, 5 into 2, 10. So 10 plus a dash square plus b dash square, and the data is I think 6 times 1, 2, 3, 4, 5, 6 minus the mean of the entire thing, which is just a dash plus b dash divided by 6 whole square. I think that is the formula for variance. Now to solve this further, what I will do, I will write it as maybe taking LCM as 36 here. So it will become 60 plus 6a square minus a square. So it will be 5a dash square. Similarly 5b dash square. And here because of 2ab term, I think it will be minus 2a dash b dash. 2a dash b dash. Okay. Now minimum will depend upon the choice of a dash and b dash. Now please see, this is a quadratic in a dash, you can say, or in b dash, but you can see its discriminant is negative. If I consider this to be quadratic in a dash, its discriminant is negative. I will write it in another way. Then also it will be concluded, maybe the discriminant being negative I will not require. Then please see, I can write it as 60 upon 36 plus, I think I can make the complete square here by writing it as 5 outside and a dash plus a dash minus, actually not plus, a dash minus 1 upon 5 into b dash whole square. Let us check. A dash square is completed, and 2ab term minus 2a dash b dash upon 5 into 5, that is also completed. And then we have to add here a term for this 5b square, because we are having as of now only b dash square upon 5. After multiplying this 5, it is b dash upon 5, b dash square upon 5. So it will be, I think, 24 b dash square upon 5. Let me just check. B dash square upon 5 plus this. Yeah, correct. Okay, and whole divided by 36. Now you can see it's a perfect square here and perfect square here. They both will be having positive values. Least value can be when they both are 0, 0. Okay, so this minimum variance only if this b dash, a dash both becomes equal to 0, 0. Because if they are not 0, 0, they will have some positive value which will add to your value of this 60 upon 36. So minimum only if a dash b dash is equal to 0, 0, which means because a dash b dash were a minus 3, b minus 3, so a equal to 3, b equal to 3. I think the same thing which I was saying in the beginning. And the minimum value is 60 upon 36, that is if you divide by 12, so 5 upon 3. So minimum value of variance is 5 by 3, that is also given here. That is also correct. So wrong answer is D here. Now coming to question number 19, R is a relation from A to A where n of A is 5. The number of such relations that are symmetric but not reflexive are this, where A is odd number, then A plus B we have to find. Now please see, if A is having 1, 2, 3, 4, 5 elements and my relation is from A to A, 1, 2, 3, 4, 5. Now relation is always a subset of A into A. A into A, if you write, it is equal to 1, 1, 1, 2, 1, 5, and 2, 1, 2, 2, and 2, 5, and so on, and last 5, 5. Now this function, if we want to be symmetric, first let us see just symmetric, not reflexive. If it is only symmetric, then there are 5 elements which are having same entries like 1, 1, 2, 2, up to 5, 5. There are total 25 such entries, total 25 entries. Out of 25, 5 are these entries. And then remaining 20 entries are such that if one of them is 1, 2, then other is 2, 1, like that. These are total 20 entries. Okay. Now, if we want this relation to be symmetric, if I choose 1, 2, I have to choose 2, 1. So out of these 20 of entries, I have independently only 10 entries. Because if I choose 1, 2, I do not have option that I do not choose 2, 1. I have to choose it. So only 10 options for such ordered pairs and 5 options of such ordered pairs. So for all symmetric relations, it will be 2 raised to the power 15. 5 for such, I can choose this, I may not choose this, I can choose this, or I may not choose this. So 2 into 2 into 2, 2 power 5 options for these, and 2 power 10 for these, because either this entire thing will be there or entire thing will not be there. So only 2 power 10 options. So 2 power 15 is total symmetric functions. Now if I have to choose symmetric plus reflexive, now you know it, reflexive means all such entries has to be there in the relation 1 1 2 2 3 3 4 4 5 5. So these I cannot choose now, they have to be there. If this relation is reflexive, I can only choose from these 20, and that will be again done in back 2 power 10 only. So symmetric is this, symmetric plus reflexive is there. If you want symmetric but not reflexive, I have to subtract 2 power 15 by 2 power 10. So it will become 2 power 5 common, or maybe 2 power 5 minus 1 into 2 power 10. 2 power 5 is 32, so 31 into 2 power 10. So that is the answer. So here A is odd number, so A is 31, B is 10, so A plus B will be equal to 41. That is the answer. Now coming to question number 20, it says A is equal to 6i cap plus 9j cap plus 12k cap, and similarly we are given B in terms of alpha, and C is the vector such that A cross C is equal to A cross B. We are given A dot C is equal to minus 12 and C dot this thing is equal to 5. Okay. Now whenever we are given such relation, we should first understand it is like A cross C minus B is equal to null vector. Okay. Now if it is so, then C minus B will be equal to parallel to vector A, so I can write it as K times A. Okay, so my vector C becomes equal to B plus KA. Now we are given dot of C with A and with one more vector 1i minus 2j plus k as 5. So if we put 1 by 1 here, I think we will be able to find K, and then we will be able to find alpha and also the vector C. Now this vector, if you look at this is having dot with A to be equal to 0, 6 minus 18 plus 12. So I will first take dot of this thing. So C dot this, which is equal to 5 here. So it will be B, that is this thing, B dot this, that will be equal to alpha minus 22 minus 2 plus 0, because A dot this thing is 0, so I don't need to write anything here. From this alpha we are getting to be equal to 29. So we are getting alpha to be equal to 29, and then another thing that I will take the dot of C with A here, that is equal to minus 12 on the left hand side. If you take dot of A with this B, that means taking dot here, already we have got alpha equal to 29. So 29 into 6 plus 99 minus 24. That is what we are getting, A dot B. I have taken dot of this equation with A on both sides. So minus 12 here, B dot A is this thing, 6 alpha plus 99 minus 24. Yeah, that's right. Plus K times A square. And A square would be that if you take, I think, 3 common, so we can write it as 9 here, then it will be 2, 3 and 4. If you add and square them, I think we get 29 here. Okay, now from this thing, I think we can find the value of K. Okay, let us see. I think this 24, if I take, then it will become 12. 12 minus 99 is, I think, 87. 12, this 24 will go that side. So 12 minus 99 is minus 87. Minus 87 minus 29 into 6 is equal to K into 9 into 29. I think 29 divides 87 3 times. So minus 3 minus 6 is equal to 9K. So this gives us K as equal to minus 1. Minus 1. Okay. So K is minus 1. So we will be able to get the value of C from here. C will be just B minus A. C will be this B minus A. So 29 minus 6 is 23 I cap plus 2 J cap, and minus 2 minus 12 is minus 14K cap. Okay, and we have to find the mod of this thing. So options are like this. I think we need to calculate the squares here. Yeah. 23 square is how much? 23 into 3, 69. 69. And 23 into 46 plus 6. 529, yeah, 529. Plus 4 plus 196. 196 plus 4, 200. So 729. Okay. So 1729 is a perfect square. So mod of C will be equal to 27. Mod of C will be equal to 27. That is B option. Okay. So question number 20 is done. Here 27. Now coming to question number 21. Here we are given A into adjoint of A square equal to this matrix, and absolute value of sum of diagonal elements of adjoint of A is. Okay. Now please see, A into adjoint of A square. I am using the property that adjoint of AB is equal to adjoint of B into adjoint of A. Using this property, I think adjoint of A square can be written as adjoint of A into adjoint of A is equal to this matrix which they have given. Now A into adjoint of A is determinant of A into I. I, if you multiply it here, will be nothing but adjoint of A itself is equal to this matrix. Now adjoint of A, to find adjoint of A, I think we need to take the determinant of this entire thing. Okay. If I take the determinant of this entire thing, it will be determinant of A into determinant of adjoint of A square. Okay, and that is equal to, I think we can open in the second column. So this, if I open, so 1 minus 2, that is minus 1. Now here, this is determinant of A. This would be, because A is 3 into 3 matrix, so it will be determinant of A square whole square is equal to minus 1. So this gives us determinant of A power 5 to be minus 1. So determinant of A to be equal to minus 1. Okay, so here this will be minus 1. So if I remove from here, I just need to put minus sign here. So adjoint of A will be just minus of this thing, and they are asking the absolute value of sum of diagonal elements. So it will be 1 plus 1 plus 1, 3. So answer for this question has to be 3. Yeah. Coming to question number 22, here we are given that if lines this and this are intersecting, their possible point of intersection is. Now these two lines where lambda square is not equal to 2 are intersecting. Now to know whether they are intersecting or not, there can be two methods. So one is that you take some point here, and then equate them, or we make formula, shortest distance formula, we use shortest distance formula and make that equal to 0. Okay, I think I'll go with that thing. Shortest distance has to be equal to 0, and this shortest distance formula has two things, one in numerator, one in denominator. So the numerator thing has to be 0, then only it can become 0. And the first row of this numerator thing, actually the formula is in terms of determinant, whose first row is given by the difference of points lying on those lines. First line is having point 1, 2, minus 3. Second line is having point 3, 2, 1 here. So if you take difference, so 3 minus 1, then 0, and then it is 4. Second row is the direction ratios of first line. So 1, 2, lambda square, and then 1, mu square, and 2. That has to be equal to 0. Now we can use some property. Actually, I can multiply first column by 2 and subtract the last column. First two column I am not changing at all. So 4 minus 4 is 0. Lambda square minus 2, and here also I am getting 0. That's great. So I think we can expand along first row or the last column, both the same things, both are same thing. So first row, if I expand, it will be 2 into this minus mu square into lambda square minus 2 is equal to 0. So from this we will be getting mu square is equal to 0. We will be getting mu square is equal to 0 because we are given lambda square is not equal to 2. Actually, if this becomes equal to 2, there are chances they both become parallel. So that's why maybe it is given here mu square is equal to 0. Now if mu square is equal to 0, now I will take point on this, equating this is equal to, let us say, k. Any point lying on this line would be k plus 3. Okay, and then this is 0, so it will be just 2 here, and then 2k plus 1. That is 1 point. Likewise, if I take some point in terms of, let's say, some constant nu, it will be nu plus 1, 2 nu minus 2, 2 nu plus 2 actually, and here it will be nu into lambda square plus 3, minus 3 actually. Now these 2 points should be same for certain value of k and certain value of nu. Comparing their y coordinates, I think we get nu to be equal to 0, and if nu is 0, the point of intersection would be 1, 2, minus 3. In fact, this can be obtained if we take k equal to, I think, -2 also. If you put k is equal to -2, it will become 1, this will be 2, and that will be -3. So that is my point of intersection, and we are asked alpha plus beta plus gamma, it is equal to 0, because 1, 2, -3, 0. Now coming to question number 23, here we are given minimum area of triangle formed by straight lines passing through a fixed point 3, 1 and cutting positive integral intercepts on coordinate axis. Now please see, if we are given 3, 1 point like this, which is cutting positive integral intercept a, 0 here and 0, b here, let us say, and we are asked the minimum area of triangle formed by straight line passing through fixed point 3, 1 and cutting positive integral intercept on coordinate axis is. So this is the area which we are looking for. OAB is the area we are looking for. Now let me tell you one result. This area is always minimum when this 3, 1 is the midpoint of AB, and if it is so, then this A will become 6, 0, this will become 0, 2, and my minimum area will be 6 into 2 by 2, that is 6. If you know this result, it is direct, but if you don't know, then also we can solve it. Please see, the equation of this line will be x upon a plus y upon b is equal to 1, and 3, 1 lies on it. So 3 by a plus 1 by b is equal to 1. Okay, and we are looking for area as AB upon 2. Okay, now if I apply AMGM here on 3 upon A and 1 upon B, AMGM on 3 upon A and 1 upon B, so that is the AM, which is equal to 1 upon 2. It will be greater than or equal to 3 upon AB whole power 1 upon 2. Okay, from this we will be able to get AB to be AB, I think I can bring it here, greater than or equal to, after doing the squaring, 4 into 3, 12. So AB will be always greater than or equal to 12, and the minimum will be when 3 upon A is equal to 1 upon B. And you can check, it will happen only if your A is equal to 6 and B is equal to 2. Okay, so it is proved that this will be midpoint when this area is minimum. AB is greater than or equal to 12, so this delta minimum would be equal to 6. So answer for this question is 6. Okay, moving to the next question, 24. Let n be the number of ways in which 4 boys and 5 girls can stand in a queue such that all girls stand consecutively in a queue. Okay, so n is equal to when 5 girls stand consecutively in a queue, so we will assume 5 girls to be 1 unit, and 4 boys can stand anywhere, so they are different units. So total 5 units are there whom you can arrange in 5 factorial ways, but 5 girls inside their unit can be arranged in 5 factorial ways also. So n will be equal to 5 factorial into 5 factorial. Now we are given n is equal to number of ways in which 4 boys, 5 girls same can stand in a queue such that exactly 4 girls stand consecutively in the queue. Okay, that means we have to choose which 4 girls are going to stand consecutively, 5C 4 ways. Then what I will do, I will arrange 4 boys, let us say B1, B2, B3, B4. They are standing in 4 factorial ways like this. Now 5C 4 ways, we chose 4 girls who are going to stand consecutively, and 5th girl will be standing somewhere else. Now for 4 girls and the 1 girl, I need 2 different spaces so that these 5 do not come together. So out of these 1, 2, 3, 4, 5 gaps, we say I have to choose 2 gaps in which one of the gap will be occupied by the 4 girls and 1 gap will be occupied by the 1 remaining girl. That will be done in 2 factorial. This 2 factorial is for what? 5C2 is to choose 2 gaps, and these 2 gaps will be filled by 2 factorial ways. 1 gap will be filled by 4 girls, 1 by 1 girl. So 2 factorial, and into those 4 girls once again can be arranged in 4 factorial in their gap. So this is the total m value. Now they are asking m upon n. So here I think 5C4 is 5. 5 into 4 factorial will be 5 factorial. So this 1 5 factorial, this 5 factorial I can cancel. Then remaining thing is here 10. 5C2 is 10 into 2 factorial into 4 factorial upon 5 factorial. Okay, 4 factorial cancels 5 factorial 5 times, 5 cancels 10 2 times. So 2 into 2 is 4 is the answer of this question. Yeah. Now this is the last question of the paper. On a normal standard dice, one of the 21 dots from any one of the 6 faces is removed at random, with each dot equally likely to be chosen. The die is then rolled. The probability that top face has odd number of dots is p. Then we have to find 21p minus 5. Okay, so what they are saying that we are having 1 dot, 2 dots, 3 dots, then we are having 4 dots, and I think we are having 5 dots like this, then we are having 6 dots like this. Okay, on a face of a dice. These are total 21. You can check. Now we have to choose one of the 6. We have to choose one of the 21 dots from any one of the 6 faces removed at random. So any dot being chosen equally likely. So suppose this dot is chosen, its probability will be 1 upon 21. For this also 1 upon 21. For this also 1 upon 21, like that. Okay. Now a dice is then rolled. The probability then top face has odd number of dice. Okay, fine. Now suppose my dice chosen was this. Its probability will be 1 upon 21. Now this face will be having 0 number of dice. This will be having 2. This will be 3, 4, 5, 6. Now odd number of dots are there now only on this and this. So probability of getting odd number on the dice will be now 2 upon 6 for this 1 upon 21. Now same would be the case if you have chosen 3 dots from this to be removed, whose probability will be 3 upon 21. If 1 dot is removed from here, then remaining dots would be 2 here. Then faces with odd number of dots would be this and this only. All others would be having even number of dots. So here also 2 upon 6. Same will be the case if my one of the dot is chosen from these 5 dots, whose probability would be 5 upon 21, and again the probability will be 2 upon 6 for odd for the face having odd dots on it. But if you choose dots from this face having 2 dots, its probability will be 2 upon 21. In that case, if 1 dot is taken from here, this will also be having 1 dot. So faces with odd number of dots would be 1, 2, 3, 4. So here the probability will be 4 upon 6. Similarly, if you take 1 dot from here, its probability would be 4 upon 21, and then we are having 4 faces with odd number of dots. Similarly, 6 upon 21 into I think 4 upon 6. So that will be the probability. Here we can calculate these two separately. 2 upon 6 will be multiplied with 1 plus 3 plus 5, 4 plus 5, 9 upon 21. 9 upon 21 is 3 upon 7 plus 4 upon 6 will be multiplied with 4 upon 6 will be multiplied with 2 plus 4, 6, 6 plus 6, 12 upon 21, that is 4 upon 7. Yeah. So here we are getting 6 or maybe 2 plus 2 into 3, 6 plus 16, 22 upon 42. So this is 11 upon 21. 11 upon 21, and this is the probability p. Then 21p minus 5 will be 11 minus 5. So answer for this will be 6. Okay, let us see the answer here. Yes, 6. So this completes the solutioning of this paper. I hope you will like the solutions of these questions. So that's all for today. Thank you so much, bacho. I'll meet you in some other paper very soon. Bye.